I welcome all you JEE aspirants right there. I am starting with this new physical chemistry high weightage chapter of atomic structure. Remember few things about this chapter. Point number 1, it minimum offers 2 questions, sometimes 3, and questions from atomic structure. This theory will also be helping you in physics because physics also asks atomic structure. So essentially, per se, for chemistry, it is more than 8% of your paper. So this few hours will give you 8%. Advantage number 1. Advantage number 2, this chapter will be a foundation chapter for your entire inorganic chemistry. So if you want to learn inorganic chemistry logically, this chapter should be your kickstart foundation. And point number 3, you do not afford to lose or leave this chapter because this is a very simple yet a very crucial chapter in which right now I will be dealing with very few logics and NTA designs paper every time onto those few concepts and just plays with the numerical value. So let us dive deep into this atomic structure chapter. Do not worry about taking those notes because all the chapter notes, the related questions, the DPP will be provided to you. You just have to go to the description box, just click the link for our PW app, enroll for this Elevate JEE crash course, and you will be getting all the content over there. Let's begin. So let us begin and continue to dig into this beautiful physical chemistry chapter of chemistry, which is atomic structure. In this chapter, we'll be discussing the discovery of fundamental particles, followed by the atomic models which were proposed. And before the proposal of Bohr model, what were the developments, the Bohr model, and the number of famous problems associated with it. And we will finish off with quantum model. Quantum model, we'll be finishing everything. You do not have to worry. Sit back, relax, and just enjoy this ride. So, discovery of fundamental particle. Dalton said, sir, atom is the smallest particle. But no. After discovery of fundamental particles, this Dalton's theory was neglected, as we have discussed in the previous short for mole concept. What was the fundamental particle which was first discovered? Sir, electrons. Although these things you know since foundation classes, but I'm summing it up because some theoretical questions obviously you will see. So what was the first fundamental particles which was discovered? Electron. How this electron was discovered? This electron was discovered by cathode ray experiment. After the discovery of electrons, what was the chronology? The specific charge. And remember, specific charge is the ratio of charge upon mass of any species. So actually, Thomson did a deflection technique and found this charge to mass ratio of electron, which is commonly termed as specific charge. After that, Millikan did an experiment by which electronic charge was experimentally determined. So we knew the E by M ratio, we knew the value of E. So mass of electron was known to people. Later on, Goldstein did the same experiment as cathode ray, but with perforated cathode. What is a perforated cathode? A cathode having holes. And that was named as anode ray experiment because it gave rise to the discovery of proton. And in the last, because neutron is neutral, so it was discovered by Chadwick at the last. Moving on, some details regarding cathode ray experiment. We very well know what it is. A discharge tube was taken. What is a discharge tube? A glass vessel. Gas at very low pressure was placed inside that chamber, that container, and a heavy potential was applied using the metal electrodes. The battery, a heavy battery, the negative terminal of the battery was connected with the terminal, became negatively charged. Some negatively charged species start, although at that point of time we didn't know that these particles are negative, which were later known by the properties. I'll be discussing those properties also because again, theory is also loved by JEE in those ABCD questions. So make note of all these things. I mean, do not note them. PDFs will be provided, but make note of revising these things properly. So some particles were traveling from this side to positive side. Now, sir, can you see these electrons? No. That's why the pressure of the gas was kept very minimal. Why? Because as of now we know electron has a tendency to give energy and ionize every species. For example, over here hydrogen gas was used. For example, over here, if hydrogen gas is used, so first of all, the energy that is carried by those particles at that point of time, people didn't know what are these particles. Now we know they are electrons. What they'll do, they'll provide energy to the gaseous molecule and break it into atomic atoms, atomic gaseous species. Now these atoms, when again they are supplied, because this supply of electrons, this supply of these particles are continuous. What these particles can do, we very well know that there is a nucleus and electron of hydrogen would also be revolving around its nucleus, because we know as of now what is an atom through our mole concept basics. So the energy carried by the electron will ionize this hydrogen atom, and this hydrogen atom will form H plus, producing more number of electrons. So all these electrons along with the electrons that are coming from the battery, they create a stream of charge, negative charge. Minus, as of now we know it will move towards plus. But if I am flowing this side, you can watch me because I am a big particle. But these electrons are very small. So how come cathode ray experiment, how come these guys saw them? I mean, not with naked eyes. A fluorescent substance like zinc sulfide. What is a fluorescent substance? Which shines when charge falls on them. So that's why a green glow was seen behind the anode. So people came to know, yes, there is a particle who is traveling from cathode to anode, and later these particles were named as electrons. Moving ahead, some properties, as I've told you, some properties of cathode rays. When this experiment was going on, these rays were traveling and they had the capacity to project a shadow of an object. So because they had a capacity to project the shadow just behind that object, that means they travel in a straight line. So first property is they travel in a straight line. Second property is because when you just place a very lightweight pedal, it starts moving. That means they must be applying some momentum on this paddle wheel. So that means it was indicated by this experiment that they must contain some mechanical effect, mechanical property. They'll have some mass. This is the second property. The third property is obviously, how we came to know they are negatively charged, because when subjected to electric field, they deviated toward the positive plate. So they are negatively charged. Moving ahead. Then I told you, Thomson did a deflection experiment. He calculated by you can always change the electricity, the electric field apply using a rheostat that you will be dealing in your physics. So Thomson, by changing this potential of the electric potential applied, he saw that these particles were deflecting at different angles. He has done some of its mathematical calculations and came out with the value of specific charge for these particles. So the value of charge to mass ratio of electron came out to be 1.76 into 10 raised to the power 11 unit coulomb per kg. And after this specific charge, okay, one thing, the specific charge of cathode ray remains constant. Why? If you take any gas in that particular chamber, let's say instead of hydrogen, if I've taken helium, helium will also get ionized, helium will also create electrons. What negatively charged would be created? Sir, electrons. Electron will have same charge, electron will have same mass. So whatever gas you can take inside that chamber of cathode ray, the charge to mass ratio will be of that electron only. So for cathode ray, irrespective of the gas taken in the chamber, the E by M ratio came out to be same, which is this value. After knowing this value, Millikan was also there in some part of the world, and what he did was he did a oil drop experiment. What is an oil drop experiment? You must have used DO. the propellant action, you have to atomize any matter into such small droplets. Atomizer was introduced, droplets of matter was passed into this chamber. Because of gravity, they will fall down. Through a small hole, they were allowed to fall down. From one side, a heavy battery, as in a device which can ionize those particles, like some X-ray beam. So such an X-ray beam was used so that those particles, those droplets may get ionized. Now they'll get charge, but they have mass also. So what is the basic physics that you can apply? Sir, because of mass, gravitational pull by the earth will be effective. What is gravitational force? mg. Because of charge, because we have ionized those particles, so because of charge, can I use electric field in such a way so that I can apply force in upside? Yes. Sir, if you have a charge, then I can arrange for such negative over here, positive over here, because minus will repel each other, plus minus will attract each other. But I will not allow this force. By watching through this eyepiece, the Bilkin scientist, he was trying to balance that droplet in air. That can be viewed through this eyepiece. So, sir, in order to balance, he has to manage the applied electric potential. Yes, the electric field E value can be controlled using a rheostat. So once he has finished with the experiment, what mathematical FBD free body diagram he got? Charge on upside QE, E can be managed. Charge on the downside mg. So you can calculate charge. And the beauty he came up with is, every time, for every droplet, for every level of excitation, he found that this charge was quantized. Sir, what is quantized? This charge was always a multiple of some value, and that value now we know is E electronic charge, whose value is 1.6 into 10 raised to the power minus 9 coulomb. That means the charge that Millikan found was some integral times of E, maybe 1E, 2E, 3E, 4E, 5. What does quantization mean? You cannot have all the values. You can have certain specific values. They observed a charge of 1E. They observed a charge of 2E. They didn't observe a charge of 1.5E. So, because electronic charge is having a definite values, what are those definite value? 1E, 2E, 3E, 4E, 5E, so on. 1.5E was never carried by them. 2.7E was never carried by them. So we came up with a conclusion. Our great scientists came up with a conclusion that electronic charge is always quantized. Moving ahead, sir, now we know mass of electron also, charge on electron also. What was chronologically going on? Then somebody put holes on the cathode of the same cathode ray experiment. Became anode ray experiment. Everything is hit and trial. Remember the COVID time? The vaccination also was a hit and trial. Every scientific approach is at first place is a hit and trial method only. So instead of using the cathode, one scientist, I've already given you Goldstein, what he did is he has taken cathode with some holes. Why, sir? I told you, whenever stream of charge is flowing, they will ionize every gas. Sir, if electrons are created, you have drawn over here only, sir, positive charge will also be created. If it is hydrogen, H+, if it is helium, He2+, if it is lithium, although lithium is not a gas, if it is any gas, whenever electrons is released, the nucleus, as of now we know, people at that point of time did not know, but the positively charged nucleus will also be produced, which we as of now know nucleus is very heavy. I'm not saying a nuclear level reaction is happening, but from an atom, if electron is removed, what is left behind, my friends? A positivity, a lack of electron deficiency is a positivity with the nucleus inside it. It is not interacting, but it is present. And because it is heavy, it needs a path to move. So what that perforation, those holes were giving what? Those holes were giving space to the nucleus so that the nucleus having the deficiency of charge, as in the positively charged species, can also move. And which way the positive charged species will move? Towards negatively charged plate. Going back to the same photo, you have to observe this now. You have to observe this now. Going back to this photo, these positively charged species were moving to the negative plate. Again, a fluorescent screen was made at the end. Again, positively charged species also have positive charge, so they are also charged particle. Whenever charged particle hit a fluorescent material, a glow comes. So sometimes this a red glow, sometimes a pink glow. The color of glow depends upon the intensity of the charges that are present. So this glow indicated that no, there was electrons were, the green glow was also there. I'm not saying cathode rays were not created, they were created. But the positive rays we were unable to observe because they are heavy. So perforation allowed them to move. And once they were allowed to move, they also started hitting on the other side of the tube. And a glow came, and these particles, when same experiment was further observed for them, these particles were later named the positively charged particle called proton. Sir, but nucleus you said never react, because if nucleus start reacting, it is Hiroshima and Nagasaki. Nuclear level reaction will be taking place. I'm not saying nucleus. I'm saying electron deficient species. For example, nucleus is not reacting. Let's say if you have taken hydrogen gas. If one electron of hydrogen atom is removed, what is left? A proton inside the nucleus. Although it is not reacting, but it is there, it is present inside the nucleus, not reacting, but the deficiency of electron has created that positivity and that heavy mass. So the best way the scientists have got and observed a proton was through hydrogen. Although other gases can also be used, but their charges will be +2 if helium, +3 if lithium, plus anything if that atomic number of, according to atomic number of that atom. So the deflection technique when was done for anode rays, you tell me now mass, specific charges, charge upon mass ratio, it will change because charges of hydrogen is +1 upon mass of hydrogen. Charge of helium is +2 upon mass of helium nucleus. So charge is to mass ratio, as in specific charge for protons is never same. It is different for different gases, a very important point. Moving ahead. Then again, the properties which I was talking about is already I have met. I am discussing everything, but I'm giving you a written data so that whenever you need to revise, you can just browse through this PDF. So the same thing, pressure is also, pressure of the gas is applied, although low pressure, because we have to, in order to observe, we have to maintain some low pressure of the gas. So specific charge for anode ray for gas A, for gas B, it will not be same. Because charge will be the value of charge will be the same, but their masses will be different because their nucleuses will be different. So for hydrogen gas, the specific charge is E by M. So if somebody is asking you for anode ray, which gas can have maximum specific charge? Sir, whose mass will be minimum? Whose mass is minimum? Sir, hydrogen is the lightest atom. So specific charge for anode rays came out to be maximum for hydrogen, and for other gases it came out to be different. A very important conclusion. Moving ahead. Now, later neutrons were discovered. Sir, now for neutrons we had to hit till the nucleus. Yes. So hitting an atom so deep that its nucleus is attacked, that process is known as bombardment. That process is known as bombardment. Chadwick did this. These days, all the nuclear scientists do bombardment, but initially, Chadwick did this bombardment and found what? And found the initial experiment done was beryllium was bombarded with alpha particles. Sir, it is not written alpha. I am telling you this. What are alpha particles? What are alpha particles? What are alpha particles? My friends, alpha particles are helium plus 2. Learn this. Helium has got 2 electrons, 2 protons, 2 neutrons. 2 electrons removed, only nucleus is remaining. What the nucleus is having? 2 protons and 2 neutrons. So alpha particle, which is helium plus 2, this was bombarded as in it was so given such a high velocity that it hit inside the nucleus of beryllium. So if hit, then nucleus will interact. Any element, remember from atomic structure, any element X, over here we represent its atomic number, over here on the superscript we represent its mass number. Mass number is proton plus neutron. This is number of protons. So 4 plus 2 becomes 6. Who has 6 protons? Carbon. So carbon. 9 plus 4 is 13. But what isotope of carbon was formed? C12. Sir, where one nucleon is gone, that nucleon was later named as neutron because when it was released with tremendous amount of energy. So it was concluded that neutron has a mass equal to that of proton, but it has charge of 0 because it is a chargeless particle, hence named neutron from neutral. Moving ahead. Now, because here, although the radioactivity was in our time it was there in NCERT, but radioactivity has been removed. But because we are discussing something is hidden inside the nucleus, whenever nucleus start reacting, that substance become radioactive because it releases tremendous amount of energy. So just some basic facts about radioactivity. If I am a radioactive substance, then I have a possibility of creating lot of energy. Radio physics is all different piece of game, but we are discussing just for the sake of our examination, whatever we should know. So a radioactive particle is so energized, it is so reactive that basically it releases 3 types of heavy energy radiations: alpha rays, beta rays and gamma rays. I'm sorry, these are alpha, these are beta rays and these are gamma rays. Alpha rays, as I've already told you, has a property like of that of helium plus 2. So they'll deflect toward the negatively charged plate. Beta rays are just like what you know about electrons. So beta rays are just like electrons. So they'll deflect towards the positive charge plate. And if you keep a photographic plate, you will see that there are some gamma rays which has no deflection toward electric field. That means they are neutral. So they represent neutrons. As in gamma rays are okay. They are heavy energy radiation. They represent neutron, as in their analogy can be thought of like a neutrons, although they do not have. What are the mass they carry? Their masses are negligible. So they are not exactly neutrons. They can be thought of like neutrons. So gamma rays have no mass, no charge, heavy energy. From this, Einstein equal to mc square is more emphasized because they were just energy. What is the velocity by which they travel? They travel with the speed of light, although alpha rays travel with 1/10 of speed of light and beta rays also travel almost with speed of light. They were not getting deflected, and because they were having so much of energy, their penetrating power when they were hitting into any nucleus, their penetrating power was very large. Beta rays penetrating power is around 100 times. Alpha rays is, if alpha ray is x, beta ray is 100x and gamma ray is 10,000x. So these are some basics you should know about radioactivity. Now, sir, fundamental particles we have studied. What are they? Electrons, protons, neutrons. What are their charges? Minus E plus E, neutron 0. What are their relative charge? Minus 1 plus 1, 0. What are their mass? Already done in mole concept. This almost neutrons and protons have equal masses. But if somebody grabs your neck and ask you, no, tell me till 3 place of decimal. Proton has a mass of 1.673. Neutron is slightly heavier, 1.675. Relative masses, sir, mass of electron is negligible. So, relative masses, I am taking mass of electron to be 0. That's why when you remember mole concept, when you measure an atom, we are only focused on its nucleus, that is number of nucleons, and both neutrons and protons have a relative mass of 1. Moving ahead. Now, a very famous question which is closest distance of approach. Although mains do not love this, but I'm still discussing it. So this is just basically your class 10th physics. I'll tell you how. Energy conservation, remember? The question is telling you, the brief explanation of this is, sir, why this topic in between? This topic in between is because JEE Advanced has asked this question, and now it has a very good chance because the principle used over here is whatever we have discussed right now and some 9th, 10th class foundation basics. Energy conservation. Suppose we are familiar with alpha particles. Suppose from rest alpha particle is accelerated. Sir, alpha particle is a charge, it can be accelerated by applying some potential. So suppose a charge with let's say charge of Q, mass of m alpha is accelerated from rest with a velocity of v alpha, and it is bombarded to an atom. We know now what is an atom. If bombardment, that is, I am giving you such a high velocity that you should hit me. But here we are just giving it a not bombarding so that it cannot hit till the nucleus, because the velocity given is not that much. It is not saying it is bombarded. So it is given a velocity of v alpha. And you are supposed to tell me it can reach till what distance, because nucleus also has positive charge, alpha particle also has positive charge. So if at all it is given a velocity, this nucleus will be repelling that alpha particle also. So because it is given a velocity, it will come, and at a distance, let's say at point 2 it will stop. Let's say at point 2 it will stop. This 2 can be any point. So you have to tell me what is the distance, what is this r till this alpha particle is allowed to approach me. I am nucleus. Sir, how will you calculate? 9th, 10th class basic energy conservation. Let's say this is point 1, let's say this is point 2. So energy at point 1 will be equal to energy at point 2. What energy? Total energy. What is the basic definition? What are the two types of total energy? Sir, kinetic energy and potential energy. What is the kinetic energy of a object? Sir, half mv square, mass of that object into velocity of that. What is potential energy between two charges? Sir, k q1 q2 by r. If you do not know this, I am iterating the formula for you. So total energy at point 1 and total energy at point 2 should be equal, because energy cannot be created nor can be destroyed. So at point 1, what is the potential energy? The question is telling you this nucleus and this alpha particle are initially far apart. The distance between them is infinite. So if I am at infinite distance from a charge, I have no impact of it in my life. So potential energy at infinite distance will be 0. So potential energy will be 0. What is its kinetic energy? Yes, it is just now accelerated. Okay, so kinetic energy will be, let's say, KE1. Writing this KE1, it will be half m or mass of alpha particle into velocity of alpha particle and square, whatever velocity will be given. So this is the state 1 going to state 2. This state 2, total energy at state 2. This is, let's say, at this distance, its velocity becomes 0, because this is repelling. So at one point of time, its velocity will become 0. So if it becomes 0 at a distance of r, at this point of time, velocity has turned 0. So now kinetic energy will be 0. But now it will have some potential energy. So some potential energy now it will have at point 2. Potential energy, how can you write, sir? K q1 q2 by r. K, which is 1 upon 4 pi epsilon naught, your physics. Q1, what is this charge? Q1, what is charge on alpha particle? Sir, plus 2e. So Q1 is 2e. Q2, what is the charge on the nucleus? Sir, we do not know its atomic number. So Ze, number of proton is Z. Each proton has a charge of E. Upon what is the distance? Sir, this distance will give you the distance of closest approach asked in paper. Very important conclusion. What we have done? Nothing. So formula is half mv square is equal to k 2kZe square by r. Solve for r. It can give you any. It can hide any variable and ask you, sir, but you have asked one more problem. What is it? It is asking you if it is at a point 3. At point 2, its velocity will become 0. At point 3, its velocity is not 0. It will be at least something. So can you give me that velocity? Yes, sir. How? That formula only. Apply that formula only. How, sir? Let me help you with it. Again, I am applying total energy at point 1 will be equal to total energy at point 3. This 3. Total energy at point 1, again it will be potential energy is 0 because infinite distance. Kinetic energy will be same, half mass of alpha particle, velocity of alpha particle square is equal to. What will be total energy at point 3? It will be, this will be, it will have some kinetic energy also at point 3. It will have some potential energy also at point 3. What will be its kinetic energy, sir? Half mass of the particle will remain the same. Yes, it will have some velocity. Let's say that velocity is v. So this v can be calculated. Plus, what will be the potential energy at point 3? Sir, k, charge is same, 2e. The other charge is also same, ze, upon the distance. Let's say this distance is r1. So question can serve you maybe with some data, but this common sense you should know. I feel it's a very probable question that JEE Mains must ask. Moving ahead. After this basic question discussion, sir, fundamental particle discovered. Now move ahead. After discovery of fundamental particles, people started predicting, because Dalton became wrong, atom was not smallest particle. So how atom is constituted? By these fundamental particles. So how they are associated in that fundamental particle? There was a person at that point of time, Thomson, who did deflection technique and contributed a lot to the world of science at that point of time. His stature was so much that he was not asked many questions, and he observed one thing: atom was neutral. We all are made of atom. You touch me, am I giving you any jhatka, any shock? No. That means I'm neutral. So every matter is neutral and they are made of atom, and atom is neutral. Why atom is neutral? Because number of electrons equal to number of protons. So Thomson at that point of time, without any conclusive experiment, he just said, he just proposed, and people till now we are studying him because you can feel this, that he must be having such a stature in society, intellectual society. So he said that atom is nothing but a lump of mass, like a watermelon, like a pudding, in which positively charges is uniformly distributed. Why you buy a watermelon? For the red fruit, which is uniformly distributed in the bulk, and electrons are randomly embedded into it. But the random embedded electrons, like these black seeds, in such a way that number of protons are equal to number of electrons. So in short, atom was neutral. People agreed to it. He passed. He left his student, not son, student. The student was named Rutherford. Rutherford said, okay, my teacher passed. I will do an experiment on his behalf. He was not doubting his master. What experiment he did was, he said, okay, Thomson is right. What I should do is do some experiment to suggest, yes, my master, my guru, what he said was right. He was not trying to contradict him. So in order to obtain atom, sir, atom is not a species which you can take and bombard. Sir, atom is very small. So what he did is, he took helium, he took gold. Why? Because gold is the most malleable metal, can be drawn into sheets, so that I cannot find atom. At least I can use such a thin sheet that I can only directly relate with those atoms, connect with those atoms, attack those atoms. And in order to attack, he used alpha particle. Rutherford used alpha particle. Hence, this is known as alpha scattering experiment, or some setup like this. He bombarded alpha particles, channelized the alpha particles through a plate, and attack a gold foil. There was a photographic film by which he was observing his observation. To his surprise, what he observed, that all the alpha, what was he expecting? He was expecting there is uniform distribution of positive charge, a party is going on. Party as in people are there, people are moving around, lots of people. So if you are also a person, that is also mass, you are also mass. If you run and enter to a crowded party, what will happen to you? Your speed should get slow, but you will keep on moving. Wherever you will meet a person, you do not like that person, you are plus, he is plus, you will repel, so you will just move aside and start walking. Actually, this question was also asked. Let me show you this. Let me at least first show you this. That's why I'm discussing this theory. Was asked in 2021. If Thomson model was correct, what would have been Rutherford observed? What Rutherford would have observed? Exactly what I'm telling you. Uniform distribution of people. You are alpha particle moving inside. You rushed into this party, but when you got into the party, you will be your speed will be slow because there are people around. How will you walk? They'll hit you. They are also positive charge. You also, so your speed will get reduced, and whenever you encounter them face to face, you will move aside because plus repel. So what should be the observation? Sir, all alpha particles should pass through the gold foil by small angles with reduce. All alpha particle pass through this, should pass through the gold foil. You should pass through the party, although your speed will be less. And whenever you meet them, you just deflect slightly. So with slight deflection. So what will be your answer? D. See? So, but instead of this, what Rutherford observed? Instead of this, Rutherford observed most of the alpha particles passed with that same amount of speed, straight. No decrement of speed, no deflection. They pass straight. 90% of the alpha particle passed straight. So he concluded 90% of the atom is empty. But when they start deflecting with huge angles. And 20 out of 20,000 alpha particle, one alpha particle bounced back. So he concluded, sir, most of the atom is empty. It has nothing. All the mass is concentrated to a very small place, and that small place he called nucleus, which contains protons also and neutrons also. People ask, where are electrons? He said, electron is revolving around the nucleus just like lighter earth revolve around heavy sun, lighter moon revolve around heavy earth. The centripetal and centrifugal forces, whatever you know about gravitation of the solar system, he said it is a Brahman, it is the same. So these are some conclusions which I have just discussed with you, with one more thing. Rutherford has given a calculative approach also. He said that the radius of nucleus is somewhere around 10 raised to the power minus 8. 10 raised to the power. Radius of atom is somewhere around 10 raised to the power minus 8 centimeter. As in this radius, if you will measure, it is of the order of 10 raised to the power minus 8 centimeter. And this radius of the nucleus, if you observe, it is of the order of 10 raised to the power minus 13 centimeter. So in meters, it is 10 raised to the power minus 10. In meters, it is 10 raised to the power minus 15. I have clearly mentioned it over here so that when you revise, you should know. Moving ahead. So this size of nucleus, because size of nucleus questions can also be asked. If I am an atom and I have many number of protons, so my nucleus size will also be relatively higher. Therefore, he also, although not only Rutherford, with the contribution of some other scientists also, they came out to a conclusion that radius of the nucleus can also be found. Radius of the nucleus is nothing but some R0 times of mass number A, because nucleus contains protons also and neutrons also. So as mass number increases, radius of nucleus slightly increases. But what is its range? The value of R0 range was from 1.1 to 1.44 into 10 to the power minus 13 centimeter. This range can lie between any digit. For the case of simplicity, I have written what is the average of 1.11 and 1.44, somewhere around 1.25 into 10 to the power minus 13 centimeter is the value of this constant R0. into atomic number, into mass number A, which is protons plus neutron, raised to the power 1 by 3. Again, what is radius of nucleus? 10 raised to the power minus 13 centimeters. In meters, it is 10 raised to the power minus 15 meter. And 10 raised to the power minus 15 meter is therefore also termed as femtometer, Fermi layer. So hence the word 10 raised to the power minus 15 meter is also multiplier, which is equal to 1 FM, femtometer. So these all things you should know. Moving ahead. Now, after Rutherford has given this solar system experiment of an atom, there was a person called Maxwell. Maxwell was studying on electromagnetic radiations at that point of time, and he asked a question to Rutherford. He asked Rutherford, every charged particle when accelerating, sir, if electron is doing circular motion, it is accelerating. He mathematically proved that whenever every charged particle is accelerating, it will continuously release energy. So electron is also continuously releasing energy. He showed those spectrum data. When energy release can be observed, that observation is called spectrum. He showed that spectrum to Rutherford and asked if it is continuously losing energy, it should one time meet the electron and hit it. He has given calculations also to support this. To support what? He said nucleus is there in the center and electrons are revolving around the nucleus, continuously releasing energy. So they must be getting tired, and at one point of time they should meet nucleus. When plus minus will meet, zero, dhamaka, a blast, nothing will remain. And he has given calculative mathematics to suggest, to statistically calculate the energy released, the energy possessed by electron, the amount of energy released. He calculated this, that within a time frame of order of 10 raised to the power minus 8 seconds. Electron is giving me so much of energy that within 10 raised to the power minus 8 seconds, it should disappear. It should be vanished. It should be gone. But we all are made of matter. Our lifespan is in the order of 10 raised to the power minus 8 seconds. No. So Maxwell asked Rutherford, if no, then how your model is correct? You cannot relate Earth and Sun because Earth is revolving. But you touch this Earth, it is giving you any shock? No. So it is neutral. He said you cannot apply this to a charged particle. Rutherford has no answer to this. So Rutherford model failed because he was unable to explain even why an atom is stable. Moving ahead, who explained atom is stable? Bohr model. But before Bohr proposed his model, there were a lot of scientific developments that were taking place. And therefore, chronologically, NCERT has also done this in atomic structure, that before discussing Bohr model, NCERT explained you. That's why I am explaining you. Although the way NCERT explains is quite trivial, that's why we are required. So, after limitation of Rutherford model according to Maxwell electromagnetic theory, there were some other developments. What are those developments? First development was dual nature of electromagnetic radiation. And second was some experimental details regarding spectra. We'll be discussing them one by one. First thing is dual nature. So, how we all know that dual nature as in electrons have dual, every matter as a matter of fact has dual nature. They have particle nature also, they have wave nature also. So first let us discuss about the wave nature of matter. Matter is made up of atom, atom is made up of electron, proton, neutron. Now we are discussing of electron because it also has some mass. It was proposed that if you have to study the properties of electron, you have to consider that electron first to be a wave. And the electron wave was named as electromagnetic wave. Why? Because it had some properties. What is the property? The first property, I'm just giving you the important characteristic because wave mechanics, wave physics is of physics part. I'm using only those things which are required for chemistry. So, first property is electron is propagating along x-axis, it will create electric field also and magnetic field also. If a charge is stationary, it will only create an electric field. But if a charge start moving, it has a capacity. God has given him this grace that it can have two types of forces. It will apply electric forces also. It will apply magnetic force also. So magnetic force is just a force created by motion of electrons. And if electron is propagating along x-axis, produced electric and magnetic field are perpendicular to each other. So perpendicular to each other. So all three of them are mutually perpendicular. First characteristic, very important. Again, this thing, propagating along x-axis, y-axis, z-axis. E represents electric field, B represents magnetic field, first characteristic. Second characteristic is, sir, you are considering electron as wave. Yes, my friends, sir, wave we know from 10th standard. So again, revise. When you represent a wave, the distance between two maxima or crust or the distance between two minima or troughs is called wavelength. First thing. SI unit of wavelength is meters, but for atoms, these wavelengths are also seen in nanometer, angstrom. What is 1 nanometer? I'm giving you a rhyme. What is that rhyme? Deci, centi, milli, micro and nano. What is deci? 10 is power minus 1, 10 is power minus 2, 10 is to power minus 3, 10 is power minus 6 and 10 is power minus 9. Again the rhyme, deci, centi, milli, micro, nano, pico, but nano, till nano it is generally ours. Minus 1, minus 2, minus 3, minus 6, minus 9. Decimeter is equal to 10 to the power minus 1 meter. Nanometer is equal to 10 to the power minus 9 meter. Also, what is 1 angstrom? 1 angstrom is 10 raised to the power minus 10 meters. These are some conversions you should know because wavelength, SI unit is meter. But generally, these all multipliers for meters are also used. So, wavelength represented as lambda. How wavelength is represented? It is represented as lambda. Now, what is frequency? Sir, reciprocal of time period. Frequency of electromagnetic radiation we represent as nu. And what is nu? 1 upon time period. What is time period? If a wave is traveling from point A, reaching to a point when it is again doing another wave. This is wave 1. From this point, it is restarting the same journey. So time required by a wave to travel from this A point till this B point is time period. And 1 upon time period is frequency. Frequency is also known as cycles per second. You have seen in physics. So what is the SI unit of frequency? Hertz. Hertz is nothing but 1 upon second. Now, velocity, we very well know, sir. Nu is equal to C by lambda. If you do not know this through physics, you should say it with me 3 times. Nu is equal to C by lambda, nu is equal to C by lambda, nu is equal to C by lambda. Frequency of radiation is equal to velocity of radiation upon wavelength of radiation. Sir, velocity, why you have written C? Because electromagnetic radiation always travel with a constant speed of light. The medium, the space, they can even travel in vacuum. They do not require any medium and they always travel with a constant speed of light. What is speed of light, my friends? The value is 3 into 10 raised to the power meter per second. 10 raised to the power 8 meter per second. Now, another characteristic of electromagnetic radiations, wave number. What is wave number? Represented as nu bar. What I'm saying? Nu bar. It is nothing. It is also reciprocal of wave number. And amplitude, this you know. What is amplitude? This is the amplitude. Sir, why you have written amplitude? Actually, some good questions. Intensity of any wave is dependent on the amplitude of wave. If amplitude is high, its intensity. Intensity in general is brightness. Tivrata. Intensity of wave is proportional to amplitude square. So amplitude, this mathematics is amplitude. Moving ahead. Now, in nature, we have so many electromagnetic radiations that if we have to classify them, the classification is known as broad spectrum. Sir, how are they classified? On the basis of their use. So, scientists have discovered so many electromagnetic radiations that they have created their pattern. What is India? What is Pakistan? It is just a boundary. They have set a limit that this side of Earth is ours, that side of Earth is yours. Similarly, electromagnetic radiations are moving electrons having different frequency, different wavelength, related by nu is equal to C by lambda. All these types of various frequencies and wavelength containing electromagnetic radiations, they are of some uses. So as per their uses, they have been classified as per their values. In physics, you have to learn these values also, because in modern physics, directly questions come from that side. In chemistry, in this thing, you do not have to learn. But one thing you should remember, the spectrum idea. What is its idea? In this direction, frequency is getting increased, so they are high frequency radiations. And in the opposite direction, obviously, because nu is equal to c by lambda, as c is constant, so we definitely know nu is inversely proportional to wavelength. If you do not know this, know this. Nu is equal to c by lambda, c is constant, so frequency and wavelength are inversely proportional. So in this direction, frequency increasing, so obviously in the opposite direction, what will increase? Wavelength. So they are high wavelength radiation, they are high frequency radiation. Who is the highest although more radiations are also nomenclatured, but we are using those ranges which are useful to us. Highest frequency radiation for us are cosmic rays. From some value to some value, you do not have to learn those values. Radiation having lesser frequency are gamma rays, then X-rays, then a range of ultraviolet, then this small range of visible rays. What are visible rays? Which your eyes can see. What is visible? What your eye can see? Rainbow, VIBGYOR, VIBGYOR, violet, indigo, blue, green, yellow, orange, red. After that, the range comes of infrared region, infrared rays, then microwaves, your microwave, that is also an electromagnetic radiation. Then radio waves, frequency and amplitude modulation, physics. Then again, radio waves. So these are some radiation names you should know. And so I told you, how are they classified? Because of their uses. Have a look at some of their uses. Gamma rays. Gamma rays, all those electromagnetic radiation which are used for cancer treatment are termed as gamma rays. The gamma rays has a range. You do not have to learn that range of frequency from this frequency to this frequency. You use any radiation, they will be termed as gamma rays, because any of those radiations, if used, they can be used for cancer treatment, laser treatment. You must have heard these days. X-rays, medical pictures. Whenever your bone gets fractured, you get your X-rays. Ultraviolet, germicidal lamp. You must have seen Dettol ad. No, your hands are not washed. No, mother, I have washed my hands. I can eat. No, get into a blue light. Oh, I can see germs. Now wash with XYZ product. The blue light is ultraviolet. Ultraviolet forms germicidal lamps. Visible, these, we are sitting in a room. The light, the source of light that is illuminating your room is visible. Whatever your eyes can see are visible radiations. Infrared, heating. You must have got induction cookers these days. Infrared is also your TV remote, your AC remote. When you press that remote, an electromagnet, although you cannot see that electromagnetic because it is not visible, but your AC gets turned on or turned off. So that means some electromagnetic radiation is hitting. That is infrared region. Microwave for cooking, radio waves for signal transmission. Hello, hello. Your TV, hello, hello, your mobile phones. So all these every moving electron is electromagnetic radiation, and these are its spectrum. Moving ahead. Now, particle. If you read your wave physics, most of the property of electrons can be explained using its wave nature. But most, not all. If you see over here, it is clearly written, some of the experimental phenomena suggested that every behavior of electron cannot be understood by considering it as a wave. Some properties like black body radiation, like photoelectric effect, can only be understood if you consider electron not to be a wave, to be a particle. Like, what is black body radiation? A very famous graph given in NCERT, although we do not have to explain it. People knowing wave mechanics could not explain it. That's why some particle nature of electrons has to be considered. Now, just to give you a brief idea what is about black body radiation, suppose you must have seen, or in some videos you must have seen an iron ball. When you heat an iron ball, after heating you keep it outside. Initially it is some red or blue or some red color. When you're heating it, sometimes it appears blue also. What I'm saying is, you must have observed this. You tell me, if that is an energy source and it is giving out energy, the energy should be same. We know, because those electromagnetic radiations, you can see, that's why I'm asking you that. Electromagnetic radiation, when iron is heated, coming out should be of one color only. Why? Because that is a body, if heated, if given a certain amount of heat, it should release energy. And those energy, those frequency, that value of frequency should not change. But if iron is giving red also, sometimes it is giving some different frequency, sometimes it is, so is some person is standing over there or what? Some people, some material is over there or what? Sometimes it is throwing this ball, sometimes it is throwing this ball. Actually, one person is sitting over there. That electron is a particle only. He catches energy and throws a packet. Although later, Planck gave his theory, which suggested that it is a particle receiving energy and then throwing it back. So this black body radiation is a property which can only be explained when you consider electron to be a matter. Similarly, photoelectric effect. Now, okay, this diagram. Now, I'm just explaining. It is a statistical, it is an experimental diagram between intensity and wavelength. At a particular temperature T1, you can see, as wavelength of electromagnetic radiation increases, intensity increases. Intensity gets maximum at a value. Intensity gets maximum at a value. Let's say at lambda 1, intensity becomes maximum at temperature T1, intensity of electromagnetic radiation. If I increase the temperature to T2, again I am observing this, as wavelength is increased, intensity attains a maxima, let's say at a value of lambda 2, and then again intensity starts decreasing. This graph can never be explained by wave nature. When you go to an IIT quantum, when you will study quantum in detail, you will be able to actually derive and formulate and understand this. But till class 12, till JEE, I am telling you, this was also studied as Wien's displacement law, which said that as temperature increases, the value of lambda at which intensity peaks up decreases. So this is Wien's displacement law. If you increase the temperature, the value of wavelength which corresponds to intensity peak decreases. At temperature T1, this lambda is larger. When temperature increased, the peak is attained at a lambda which has a smaller value. Wien's displacement law. These all things can never be explained using considering electron to be a wave. You have to consider electron as a particle. Moving ahead. Now, as I told you, who has helped us to think about the particle nature of electrons? Planck. Planck said that every matter receives energy, like a black body. What is a black body? It receives energy and returns back all the energy. So I can receive radiation, I'm catching those radiation and I'm giving it back. For example, if I'm receiving 100 rupees, I'll definitely give back 100 rupees. But maybe I can give 10 packets of 10 rupees. Maybe I can give 2 packets of 50 rupees. Every body is a black body. The amount of energy it receives from outside, it throws all the energy, but in form of packets. And the packet of energy, according to quanta, according to Planck, this packet of energy was proportional to frequency of that particular packet. As in, if I'm throwing an energy packet, this energy will be proportional to the frequency of electron. Energy as in it's an energy, as in it's an electron beam. Electron beam as in it's an electromagnetic wave. Wave will definitely have a frequency. So energy of that particle will be proportional to its frequency. And because frequency is inversely proportional to wavelength, so energy is inversely proportional to wavelength of that particular packet. What was the proportionality constant? Because this was given by Planck, so whatever proportionality constant he got, it was dedicated to him, and therefore the formula becomes energy is equal to h nu, where h becomes Planck's constant, or energy of each packet can also be written as hc by lambda. This is energy of each packet. So every body is a black body, can receive 100. You give me 100 rupees, I'll take 100 rupees. You give me 1 lakh rupees, I'll take 1 lakh rupees. I'll give back that lakh of rupees, but in packets. So this is Planck's theory. And what is the value of H? Value of H is 6.626 into 10 raised to the power minus 4 joule into second. Now, if you know the value of Planck's constant, can you help me with solution of this particular question, please? So here, if you can see, you are supplied with power. Use some common sense from class 10th physics. Power is what? Power is work done per unit time. So like, just I'm curating a visual for you. You have a power source, let's say a bulb. The bulb is emitting radiations. If you have switched on that bulb, the power is consumed for how much time? For T time. So what energy that source may be sun, that source may be anything. Now, speaking of the energy, the electromagnetic radiations emitted, these electromagnetic radiations are radiated according to Planck in form of packets. These packets of energy are sometimes termed as quanta, sometimes termed as photons, although for the exact word photon is used when the source is sun, but in general it is used everywhere. So the packet of energy thrown are called quanta of energy or photons or simply electromagnetic radiations. So now you tell me, Planck has told you each line, each electromagnetic radiation has an energy of what? H nu or hc by lambda, whatever is given, either frequency or wavelength. But in time t, how many such lines, such waves are radiated? That will be number of photons or number of quanta. So we very well know power is equal to work done upon time. What is work done? Work done by the source will be the total energy given. What is energy of this one arrow, one radiation? Sir, we know it is hc by lambda. So what will be the total energy? Energy of one photon is hc by lambda, or maybe h nu, into how many photons it is creating in T time? Sir, n. So n into hc by lambda will be your total energy, and this total energy will be the work done by this source. So its power can be equated as number of photons released into hc by lambda upon this time t. So this becomes a very important conclusive formula for you, and applying this formula, you get your answer. Let us try it. Power is 25 watt in SI unit. Number of photons is n, time is t. What is the energy of each packet? Because wavelength is given, so I will use hc by lambda. And over here, what is exactly asked to you? You are asked, you have to calculate rate of emission. What is rate of emission? They have helped you with unit also. Quanta per second or photons per second. Quantum is singular, quanta is plural. For if I'm sending one packet, it is one quantum. Many packets, they are quanta. So number of packets, number of quanta per unit time. per second, because SI unit of time is second. So you have to calculate this n by t ratio. So this n by t will come out to be what? This n by t, sir, will come out to be 25 into wavelength. What is the value of wavelength? 0.57 into. Remember, I told you for wavelength, you should know the multipliers. What is micro? Deci, centi, milli, micro. Fourth finger, so -1, -2, -3, -6. So 10 raised to the power -6 upon. Now, I'm giving because see, atomic structure questions, you just have to learn these small formulas, and the most important thing is your calculations. Most of the calculation, obviously, every person on the basis of their practice, they have a pattern of calculating things. I'm also helping you with some of the tricks. What is H? I've already told you it is 6.626 into 10 raised to the power -34. What is C? Speed of light, which is 3 into 10 raised to the power 8. So this HC multiplier is used many times. If the question is an integer type question of that format with 2 place of decimal, you cannot do anything. You have to apply your whatever calculative powers you have gained through your hard work and practice. But if options are there, it will help you. How? Because approximately you can write it as 20 into 10 raised to the power -26. You have to learn this. Because when options are there, it will be saving you time. So this approximate multiplier of HC, if you will use, so it will come out to be 25. No, sorry. I have just written the numerator, which is lambda. HC will be going in the denominator. So HC will be coming over here. Here as in 20 into 10 raised to the power -26. Now, I guess if you'll solve it, there's a bit correction. If you solve directly using this data, it will come out to be 7.17 into 10 raised to the power 19. And obviously, if you'll be having options, so multiply, divide, I'm just helping you with this. But obviously, multiply, divide, if you are going to attempt JEE, that is a thing that you should practice. So solve it, you'll get the answer exact. It would be somewhere around that. And if you are putting 20, you'll be getting an approximated answer. Moving ahead. Now, already discussed. Next question. Okay, the same question was asked in JEE. You have to calculate energy of 1 mole of photon. You have to calculate energy of 1 mole of photons of radiation of wavelength 300 nanometers. So this is just the same question. What will be the energy, sir? Number of photons into energy of each photon, which is hc by lambda. How many photons? For 1 mole, you have to calculate. What is Na given? 6.02 into 10 raised to the power 23. Sometimes they give you the constant. So whatever constant they are giving, use that only. Do not use as per your mind, as per your wish. Hc, I am approximating it to be 20 into 10 raised to the power -26 upon lambda. So what is lambda? Lambda is 300 nanometer. So 300 nanometer. What is nano? Deci, centi, milli, micro, nano. Fifth finger. -1, -2, -3, 6 and 9. After 3, 3 stable. 10 raised to the power -9. So we will solve it. I guess now, if you have approximated to be 20, you have slightly increased. The exact, it is somewhere around 19 point something. So I have increased it. So whatever answer I'll be getting, it will be an increased answer. So let us formulate the power. So this is 10 to the power plus 23 minus 26. It is -3. -3. This will be becoming +9. So +6. That +6 and these two will go. So +4. So you are having 10 to the power 4 in the numerator. Now, what is there in the denominator? This is 3 1 ja, 3 2 ja. This is somewhere around 40 into 10 to the power 4. Take a 0. Now this is 400. HC is 19 point something. You has increased it. So whatever answer you have got is an increased answer, which is coming out to be 400. Why 400, sir? Because answer is in kilojoule. Whatever you have got will be in joule. So 10 raised to the power 3 you have to take out. So 1 0 will be remaining. So it will be 400 kilojoule. Lesser than that, look for an option 3.99. So whenever options are there, maths will be your piece of winning taking that extra edge and earning that extra time. Now, next question says energy E1, E2 of two radiations. Okay, have energies are given. You have to find relationship. These type of questions are also asked. I know energy is inversely proportional to wavelength. So, E1 upon E2 will be equal to lambda 2 upon lambda 1. What is the energy given for first? 75 electron volt. What is energy given for second? 300 electron volt. Sir, electron volt? Energy has a unit of joule or maybe calorie. What is electron volt? Just a second. First you solve it. So it will be 1 by 4. So 4 lambda 2 is equal to lambda 1. 4 lambda 2 is equal to lambda 1. Option 1. Bingo. Now, I'm giving you a very important conclusive formula. What is that? If you are supplied with energy in electron volt, if you are supplied energy in electron volt, for calculation it will help you. So I'm just giving it to you as a star point. Now, sir, why energy? How can energy can be calculated in electron volt? See, what is energy of one electron? What is charge of one electron? 1.6 into 10 raised to the power minus 19 coulombs. You know this. What is potential? Sir, potential through 9 standard, 10 standard physics we know. It is work done to move a charge. Okay. What is unit of work done, my friends? It is joule. What is SI unit of potential? Sir, it is volt. What is unit of charge, my friends? Sir, it is coulomb. So you tell me 1 joule is equal to charge into coulomb. 1 joule is equal to charge, coulomb into potential, volts. Sir, if electron has a charge of 1.6 into 10 raised power minus 19 coulombs, so can I write 1 eV? So E represents that electronic charge, whose value is 1.6 into 10 raised to the power minus 19 coulomb, and coulomb into volt will be replaced by joule. So my friends, this is also a very important conclusion. What is a very important conclusion? This one. 1 electron volt is nothing but 1.6 into 10 raised to the power minus 19 joule. You do not have to convert it every time. Why? Because I'm giving you one more formula. You know now energy can be calculated in electron volt as well. So if energy of any photon is given in electron volt, I am doing a conversion for you and you have to remember the conclusion. The energy of photon, the formula we know, sir, hc by lambda. You do not have to learn that hc, that 20 also, because that was in joule. Instead of this 20, the multiplier comes out to be 12400, 12,400. Remember this formula. When energy is given in electron volt, take hc as 12,400, but in that case, put your lambda in angstrom. What is 1 angstrom? It is equal to 10 raised power minus 10 meters. This formula also will be tremendously used and saving your time in time of JEE. Moving ahead. Now, one more question. The question says in a measurement of quantum efficiency. Acha. Formula is the same. They make a word problem and try to scare you, but what you have to do is keep patience and stick to your logic. So in a measurement of quantum efficiency of photosynthesis in green plants, it was found that 9 quanta of red light at this much of angstrom, that means number of photons and wavelength are given, are needed to evolve 1 molecule of oxygen. So this is the energy which during measurement you have defined, the question has defined. What is formula of total energy? Number of quanta or number of photons into hc by lambda. What is number of photons? 9 into hc, 20 into 10 raised to the power minus 26 joule upon. What is wavelength? Because it is not energy. I'm not calculating this energy in electron volt as of now. I'm doing it in joule only. So this is this much. And over here, what will be the wavelength? 6900 angstrom, as in 10 is power minus 10 meters. Everything is SI unit. This is your energy measured. What is its value? Just check. Its value will be this 0 and this 0 will get cancelled. This 0 will make it 10 is power minus 9. Minus 9 going up will become plus 9. So it will be 10 raised to the power minus 17. And this is 9 into 2 is 18. And this is 69, take 70. So 18 upon 70. Okay, we will take 0 also. So 18 and a 0. Sir, why you are taking 0? Array, increase this by 1. No, because I need a larger quantity, because with larger quantity, if you approximate, percentage of error, the error that you do lessens. So do approximation by making things larger. I'm intentionally doing this, or I would have said and that you do, and I would have moved ahead, but I'm helping you how you should do calculations to save time. So I've taken a 0 here to make it bigger, and on the bottom 69 I'm approximating to be 70. Now this 0 will get easily cancelled. 7 2 ja 14, 7 3 ja 21, so it is somewhere around 2.5, maybe 2.5, slightly higher. So this is 2.5 into 10 is power minus 18 approximately. Sir, why you are approximating? Because I'm given options. And I can see the options are quite different, are very different, has a lot of distance from each other. So I can approximate, hence approximating. So this is the energy which is measured. The question says the average energy stored in photosynthesis process for evolution of this oxygen is this much kilocalorie per mole. It is playing with unit. This is the energy measured for, this is the measured energy. It was 9 quanta of red light were needed to evolve 1 molecule of oxygen. But here 1 mole of molecule calculation is there. So I have calculated for 1 molecule. So I again have to calculate for 1 molecule. So the energy that is stored, that is equal to what? It is directly given, 111.6 kilo. So 10 raised to power 3 calorie. What is 1 calorie? Because this is in joule, SI unit. 1 calorie has 4.2 joules. So into 4.2. So joule. But this much will be released by will be stored by 1 mole. So for 1 molecule, 1 mole is storing this much. 1 mole Na is storing this much. So 1 will be storing upon Na. So this is upon 6 into 10 raised to the power 23. Because this is 10 raised to the power minus 18, let us make this also 10 raised to the power minus 18. 20 will go up and becomes minus 20. But sir, I need minus 18. So I am minus 2. I'm keeping this in mind. I'm separating this minus 2. Now recollecting the integer parts which you will calculate. So those are 111 as in 100. This is 4.2. So 4 into 100 is somewhere around 400. So 4 into 100 as in 400, or you can do one thing. This 10 raised to the power minus 2, you give it to this value. It will become 1.116. So if 1 is multiplied with 4.2, 1. This is 1.1. 10% increase 4.2 by 10. It will be, sir, 4. What is 10% of 4? 4 rupees. What is 10% of 4 rupees? 40 paisa. So 40 paisa, 4 plus 40 paisa is 4.4. It is already 4.2. So it will somewhere around 4.6. So this is 4.6 upon 6. This, at least this thing you can do. Now, because it is 4.6 upon 6, so calculating it, so 0.67 ja 48. So this is 7, 6, 6 ja 36. Oh, sorry. 6, 7 ja 42. So this is more than 7, 7.5 approximately. So this is 0.75, this is 2.5. You have to calculate efficiency. How you calculate efficiency? Output upon input. What output you are getting? 0.75. What input you are putting in for the photosynthesis? What input from radiations you are putting in? So 2.5. You calculate efficiency. Sir, how? Beta, efficiency equals output 0.75 upon input 2.5. Sir, why not written this? That's why I've made that 10 raised power similar, because it will get cancelled. Into 100 will give you the percentage. So this is 75 upon 2.5, 175 upon 2.5, or 750 upon 25, 25, 3, oh, 30%. See? Hello. So into why I have done this calculation with you. So in order to make you understand, if you have a way of doing calculation, do it. But I wanted, because in mole also and over here also I'll be doing this, do calculation by yourself. You will do calculation, but I can help. If I can help at some places, I'm doing it. So you can also do, like, maybe I would have helped in your calculation part. Moving ahead. Photoelectric effect. Now, for electron, most of the properties was explained by what? Most of the properties, sir, it was explained by their wave nature. But black body radiation was explained by their particle nature. Particle nature as in, there is some particle, there is some electron, there is some matter who is sitting in an atom, in all the atoms, receiving energy and then throwing it out as a black body. One more effect which cannot be explained by considering electron as a wave, you have to consider electron as a particle sitting inside matter, is photoelectric effect, and very famous for JEE questions. Now, what is photoelectric effect? Radiations from outside, from any source, fall into metal surface. Metal are known to have free electrons, so metal gets ejected, and these metals can these ejected electrons, when moving, they will create a current. You can either store that current in your household. The solar battery that you charge with solar panels operates just on the principle of photoelectric effect. Now, there's some characteristic of photoelectric effect. It says the electrons are ejected from metal surface when obviously a beam has to strike that metal surface. And when that beam strikes and electrons accept it, there is no time lag. That electron will gain energy and say, okay, I'm coming. It gains energy and puck. What I say? The electron goes to the metal surface and ejects out. To that ejection, I say they puck. With puck, they come out. Like, with that puck, they come out. So, what I'm saying is, see, you have this metal surface, electrons must be there inside the bulk. Bhai, electron will be present inside the bulk. This is a metal surface. Electron, because let's say if it is iron, if it is an iron rod, I am picking up this iron rod, I'll get a jhatka or a shock? No. That means metal has free electrons, but these free electrons are only ejected when electron supply comes into it. They are conductors. If you just pick them up, will it give you any shock? Why? Because those electrons are attracted by the positive ions in the matter. You just pick up an iron rod, you will not get a shock. That means electrons are there. They are free electrons. But why you're not getting shock? Because they are attracted by their positive ions. They have got free electrons, but in order to make those free electrons free, you have to surrender. You have to give some energy to them. When they are connected in an electric supply, then they pass current. So, electron embedded in the metal surface, when light radiation falls on it, let's say this is a light radiation. As soon as this electron is taking this radiation, it immediately gains that energy, and do not wait, immediately it starts moving. So first movement will be with it is attracted by the positive ions, so it has to break away from those positive ions. No, I'm going, leave me. But that will require some energy. So it will come to the metal surface, and the amount of energy required to come to the metal surface, we call it phi. Threshold energy or work function energy for the metal. Every metal will have different work function, and as soon as the metal has reached the surface of the metal, it will get ejected. It will get ejected with some kinetic energy. So what will be the mathematical energy conservation? Sir, if EI is energy of incident radiation, phi is work function, and this is kinetic energy, so you can very well formulate. Sir, incident energy is equal to, if 100 rupees have come, let's say 30 rupees it requires to reach the metal surface, which is work function energy. And now after reaching the surface, it has 70 rupees. So with 70 rupees, it will move, it will travel, it will take that 70 rupees and roam out in the world. With that, kinetic energy. So this is the photoelectric mathematical equation. Moving ahead. Number of electrons ejected is proportional. Okay. Now, as soon as you increase the frequency, if what is energy of incident radiation, it is equal to h nu or hc by lambda. If incident radiation frequency is given, you write h nu. If incident radiation wavelength is given, you calculate using hc by lambda. So nu I and lambda I are frequency and wavelength of incident radiation, whatever the question is supplying to you. So if I'm increasing this frequency, what will be increased? Increasing frequency as in increasing energy, or decreasing wavelength as in increasing energy. So if I'm increasing frequency or decreasing wavelength, I'm supplying more energy. That means I'm not giving 100 rupees, I'm giving 200 rupees. Work function is 30 only. So with what amount of money it will roam? Sir, more money. Initially when you were giving 100, it was consuming 30 to reach the metal surface, so 30 wasted. But with moving with 70, if you are giving 100, so it will move with 170. So if you increase the energy or frequency or decrease the wavelength, kinetic energy of electron increases. Number of electrons, this electron will only get ejected, right? Number of electrons do not get increased by changing frequency or wavelength. Number of photons, number of electrons ejection increases when this electron is getting this photon. There should be some other electron, supply it with different photon. So number of photons increases when intensity increases, brightness increases. This you should keep in mind. So this is a very beautiful thing. JEE has asked it so many times. Number of electrons is ejected is proportional to intensity, not frequency. Moving ahead. Next, for each metal, it says for each metal, this I have already told you. The threshold thing. Threshold energy or work function energy, you know. Sir, if phi is the threshold energy, you tell me, how can you calculate this phi? Sir, phi is the minimum energy required. So if phi is the minimum energy required, so minimum energy is equal to h nu naught. What is nu naught? Sir, energy can be calculated using Planck. So instead of nu, I'm writing nu naught. So if this is threshold energy, so that will be termed as threshold frequency. If it is threshold energy, then this will be termed as threshold wavelength. What is this energy? The minimum energy. 30 rupees you have to give if I supply a photon of energy 10 rupees. This electron, sir, need 30 rupees to reach at least to the metal surface. If you have supplied 10 rupees, I have not even reached the surface. How will I eject? How will I go? So photoelectric effect will not be seen. That's why I'm telling you, phi is the minimum energy incident radiation should have. Or else, if you're having less, I will take that energy, but I cannot get ejected because I have not even reached the metal surface. So phi is the minimum energy. So if energy is minimum, the corresponding frequency is minimum. And corresponding wavelength is maximum. So threshold wavelength is the maximum wavelength and threshold frequency is the minimum frequency. Keep this English also in mind. So this is written also, it is the minimum frequency. And photoelectric effect is only observed when frequency, incident frequency is greater than threshold frequency. Moving ahead. Okay, now some very beautiful graphs. Advanced started asking them and now mains also. So you tell me, frequency and kinetic energy of electrons, sir. Electron kinetic energy and frequency. Energy, as you increase energy, kinetic energy will also get increased. But you will not get any kinetic energy till the kinetic energy is zero. Till this frequency has reached a minimum value of nu naught. After nu naught, as kinetic energy increases, as frequency increases, kinetic energy will also increase. But till threshold, no ejection. Now, intensity and kinetic energy of electrons, sir. Intensity is as in increases number of photons. So, keeping in mind, if whatever intensity, however number of photons are coming, they should have an energy greater than threshold energy. So I'm assuming that the energy coming is more than threshold energy. So because it is more than threshold energy, so some kinetic energy will be there. Now you increase intensity, number of electrons having that kinetic energy increases, but kinetic energy of all the ejected electrons will remain the same. So intensity has nothing to do with kinetic energy. It will be a straight line. Okay, next, moving ahead. Acha, number of electrons ejected, sometimes in English, in questions, in word problems, number of photoelectrons ejected, because this is their electrons are ejected by photoelectrons, so photoelectrons. Number of photoelectrons ejected are also represented as electric current, because if they are ejected, current will be coming. So number of photoelectrons ejected or electric current, both are the same. Now, if you increase frequency, sir, increase frequency increases kinetic energy, not the number of photons or electric current. But when this electric current will start, even if one photon is coming out, when will it come out? If the frequency is at least reached till threshold. And once it has reached threshold, whatever, if you increase frequency, energy increases, number of photons will remain the same. I am only ejecting, but I will increase with more, I will move with more kinetic energy. My number will not change. My number will increase when number of photons will increase. Hello. So this will be a straight line. Moving here. Again, keeping in mind, incident frequency is greater than threshold frequency. So as intensity increases, so it will be a straight line. It will be a straight line increasing, because as light brightness increases, number of photons also increases. These are some very beautiful graphs that you should know. Now, moving on to the question. The question says, what is the work function of metal if light of wavelength, the wavelength is given out to be 4000 angstrom, generates photoelectron of velocity this much? Solve it. So the work function we have to calculate over here is in options are given, electron volts. Sir, so what we'll do? Incident radiation wavelength, you know, remember the formula. So what will be the energy of these incident radiations, my friend? You have to remember, sir, it is 12400 divided by wavelength, and it has to be in angstrom, given in angstrom. Bingo, sir. So that means this is 3.1 electron volt directly. So you know the energy of incident radiation. What are you supposed to calculate in this question? Sir, if I know incident radiation, I know through the mathematical energy conservation of work function, photoelectric effect, that it is equal to work function plus kinetic energy. This I know in electron volt, this I have to calculate. So what will be the kinetic energy? That is only I have to calculate. But unit dimension has to be applied, because kinetic, you are given with velocity of electron, and velocity is an SI unit. So kinetic, what is the SI unit of energy? Joule. So for kinetic energy, I'm separately calculating kinetic energy is equal to half mass into velocity square. But after putting everything in SI unit, this energy would be coming out in joule. Sir, I know 1 eV, 1 electron volt is equal to 1.6 into 10 raised to the power minus 19 joule. So what is 1 joule? This has to go into the denominator. So if this value is coming out to be in joule, but you need this data in electron volt, so what I have to do? I have to divide by 1.6 into 10 raised to the power minus 19, and this joule in that case will be converted to electron volt. So you can put everything in SI unit. By just placing this in the denominator, I have converted joule to electron volt. So just now it's the most difficult part, actually, the mathematics practice, and you should get the answer. So I'm just giving you the data. What is mass? Achha, mass of electron we remember also, although it is given only 9.1 into 10 raised to the power minus 31. Achha. Sometimes when this data are given, be very watchful in using only that data. Although when options are given, it does not make that difference, but when integer type question comes, it makes huge difference. So this into, what is the velocity given? 6 into, so square of that velocity, so 6, 36. And what is square of 10 raised to the power 5? Sir, it is 10 raised to the power 10 upon this data 1.6 into 10 raised to the power minus 19. I guess it will also be easily solved. Something around 1 will come. So if this 3 would be subtracted by some 1 point something, so I guess you will be getting answer 2.1. Mathematics calculation you have to do. Moving ahead. The next question says work function of sodium metal is given out to be 4.41 into 10 to the power minus 19 joule. Now, if photons of wavelength 300 nanometer are incident on the metal, kinetic energy of the ejected electron. Now you have to tell me kinetic. Now, this question is, you have to tell the value in the form of dash into 10 raised to the power minus 21. So you have to be very precise with the calculation. Moreover, what is the exact value of H? 6.626. It is already approximating and telling you, you take this. If you take this, strictly take this, and then you will get the answer, because here the significant figures will obviously matter. Because it is given 10 to the power minus 19, asked 10 to the power minus 21. So 2 decimals, it is asking more decimal places. So you have to be very precise with the calculation. I have repeated it many times. So let me give you the chemistry behind it. Work function is given. Okay, sir. Phi is given. Thank you. Phi is given. If photons of wavelength 300 nanometers, so lambda given, sir. So first you calculate the energy of incident radiation. What will be the energy of incident radiation? Sir, it will be equal to H into C by lambda. Be very precise with your calculation, my friends. It will be 6.63 into 10 raised to the power minus 34 into 3 into 10 raised to the power 8. So HC upon lambda. Lambda is given out to be 300 into 10 raised to the power minus 9, because it is nanometer. So this will be your energy of incident radiation. Now, after doing this, let us recollect 10 raised to the power. So this is 10 raised to the power minus 34 and 8. This we remember, it is minus 6. So this is minus 6 and this 0 and this minus 9 will become minus 7. Minus 7 go up will become plus 7. So minus 26 plus 7 becomes 10 raised to the power minus 19. Okay, sir. What about these data? This is okay. This 3 and this 3 is gone. Okay. This is pretty decent. It is 6.63 only. So 6.63 into 10 is power minus 19. But in what form you have to report the answer? 10 is power minus 21. Increase. So 2 decimal places will move forward. So it will be 663 into 10 is power minus 21. Perfect. Now moving ahead. This is the energy of incident radiation. What else you are asked? In order to calculate, okay, nothing is asked, sir. Kinetic energy you have to calculate. So kinetic energy will be equal to, sir, incident energy minus work function. Incident energy is 663. Work function increased by 2 because 10 to the power minus 21 you need. So 441. So this is 2. Acha. The calculation in such cases, thank God for sometimes mains ask good easy calculations. Okay, moving ahead. If P is the momentum of fastest ejected electron from a metal after irradiation of light having wavelength sum lambda. So first equation becomes what? First equation becomes, acha, you are asked here momentum, photoelectric effect, whatever we have till now derived, it is of kinetic energy. So first let us relate kinetic energy. In physics you must remember, but let me do it for you. So sir, we very well know kinetic energy is equal to half times of mv square. So if I calculate V will be equal to twice of kinetic energy upon mass under root. So what is momentum? Momentum is P, which is mass into velocity. If I replace this velocity by this, I can easily have P is equal to m into V. So under root of 2km. When this m goes inside, it becomes m square. So this P will be equal to under root of twice of mass into kinetic energy. What is the equation of photoelectric effect that you'll write? We write incident energy is equal to work function energy plus kinetic energy. Kinetic, instead of kinetic energy, you have to use momentum because question is given in momentum form. So kinetic energy will be equal to momentum square upon twice of mass. Hello? Okay. So if P is momentum of fastest ejected electron from a metal surface after radiation of light of wavelength lambda. So this energy is also given out to be hc by lambda. This is my equation 1. Then for 1.5 times of P momentum, the wavelength of light should be. What will be the wavelength of light for this much of momentum? Okay, sir. What we have to do now? We have to calculate the wavelength. So let's say the wavelength is hc upon lambda dash, the new wavelength. It should be equal to phi. The metal is same, but I need momentum of 1.5. What is 1.5? 15 by 10. What is 15 by 10? Sir, 3 by 2. So 3 square is 9, 2 square is 4, p square upon 2m. So you have to see one thing, my friends. This thing and this thing is same. So if I have a ratio, sir, but this is phi also over here. Read the complete question. The question is telling you, assume kinetic energy of ejected photoelectron to be very high. Sir, if I say incident energy is equal to phi plus kinetic energy, and if value of phi, value of kinetic energy is very high, if value of, let's say incident energy is equal to, let's say kinetic energy is 1 lakh rupees or 10 lakh rupees and work function is 1 rupees. So total energy, how much you have supplied? Sir, if I get a bill of 10 lakh rupees, the shopkeeper will even serve me cold drink or juice, or that juice will be costing somewhere around 100 rupees. So what my point is, like in practical life, when a small transaction is taking place, you neglect the smaller one. So here, this approximation has to be used theoretically. So I can say because work function is so small, this incident energy is approximately equal to this high value of kinetic energy. And how this thing is helping you over here? Because this phi is approximated to be 0 in with respect to the value of kinetic energy. Using this, the one variable is gone. So just divide these two equations. So if we just divide these two equations, equation 1 will give hc by lambda, so lambda will be in the denominator. Equation to hc by lambda, but this lambda dash will come to the numerator. Hc got cancelled, so this is LHS, equation 1 upon equation 2. Moving ahead, p square upon 2m, p square upon 2m will get cancelled. So in the numerator, you will be getting 1. In the denominator, you will be getting 9 by 4, which comes to be 4 by 9. So what is lambda dash? Sir, 4 lambda by 9. Any option? Yes, sir. Bingo. Moving ahead. Next question says, a light source, you are given a light source of wavelength lambda that illuminates a metal and ejects photoelectrons with kinetic energy with maximum kinetic energy of 1 electron volt. So write equation for it. What will be the equation, sir? Lambda is your incident wavelength, so incident radiation will be hc by lambda is equal to phi of that particular metal plus what is the maximum kinetic energy? 1 electron volt. I know everything is in electron volt over here. Equation 1. Another light source of wavelength lambda by 3. So instead of lambda, I am using lambda upon 3. That 3 will go to the numerator, will be equal to phi plus the maximum kinetic energy. In that case, sir, simple. It is 4 electrons. These simple questions are asked. What is the biggest problem? Is the word problem. That's why I step aside and ask you to read the question and curate the maybe the photo, the picture, the mathematical representation. This you have to curate by reading the words. So why these questions are called word problems? Because words are the probably only problem, because you have to relate those words with whatever theory you read. So I guess this is quite simple. So what we'll do is hc by lambda is already given. So hc by lambda you replace by phi plus 1. So phi plus 1 into 3 will give you 5 plus 1 into 3 will give you 3 phi plus 3 on left side, and on right side it is 5 plus 4. So 3 phi minus phi is 2 phi, gives you 1. So phi is 0.5 electron volt. Moving ahead. Next, okay, now question, you have to deal with the theory. The theory is stopping potential. Sir, photoelectric effect we know. Kinetic electron comes out with the kinetic energy. You want to stop that electron. Sir, if you want to stop that electron, apply potential in the opposite direction. That is the stopping potential. For example, if electron is coming from this metal surface, getting into this wire, you put out a battery, external battery, and you apply potential. If this is the positive terminal, so you apply a potential. This potential will go and will force the electron. You stay over there. So in order for this battery to force a potential to stop this, what energy has to be killed? Sir, kinetic energy of this electron. Whatever maximum kinetic energy of this electron is having, you should give that potential. Sir, that means what? Beta, that means formula of potential, class 9, 10, 10th. Battery should do so much of work done to move the charge. Charge is obviously the electronic charge. So this work done is what? How much work I have to do? That much work you have to do, which can kill its kinetic energy. So this work done is nothing but kinetic energy. So this, it may be electronic charge or it may be some Q, other charges, but since electrons are not, so I'm writing at E, but in general it is a charge. So you tell me, what is kinetic energy? Sir, kinetic energy formula is half mv square. Half into mass of electron into velocity of electron. And in order to stop this kinetic energy, this is the potential I'm applying. So V times of Q, whatever charge, electron has E charge, but I'm generalizing. So QV equal to half mv square, and this V will be your stopping potential. Sir, give me a question. No. Okay, practice a question. The question says, a monochromatic light of wavelength 400 nanometer. Wavelength given is 400 nanometer falls on a metal surface whose work function is given, phi is given. So first you calculate what? First you calculate, sir, because phi is in electron volt, so incident energy we calculate in electron volt. So you tell me what will be the incident energy? Sir, it will be 12400 because electron volt upon lambda. Sir, but lambda has to be in angstrom. Beta, 1 angstrom is, I'll write it for you. 1 angstrom is 10 raised to the power minus 10 meter. 1 nanometer is 10 raised to the power minus 9 meters. So just add a 0 and this nanometer will become angstrom. So this will be nothing but 400 becomes 4000 angstrom. So this is again 3.1 electron volt. This is your incident energy. Work function is 2. So what is the kinetic energy of electron? Sir, incident energy minus work function. How much it comes out to be? 3.1 minus 2 is 1.1 electron volt. So now you have to calculate the stopping potential. Sir, kinetic energy we already know. So what is the potential? I have already told you the formula. It is equal to charge into potential. Charge, what is electronic charge? E got cancelled. Sir, this much volts is the stopping potential. So 1.1 will be your stopping potential. Moving ahead. Now, moving forward, not coming back, we move forward. Moving forward to Bohr's atomic model for an atom. Now, all these development help Bohr to formulate and postulate that no, Rutherford was not wrong. Bohr did not give any other atomic model other than Rutherford. What Rutherford said, Bohr said that only. Sir, but you said Maxwell theory disapproved Rutherford and he was like, I am unable to answer you. Bohr said, no, Rutherford is right. So Maxwell again came, Bohr, how you are saying this? So Bohr replied, see Maxwell, what problem you have? Maxwell said electron is releasing so much of energy that I am mathematically telling you this is its energy, and in 10 to the power minus 8 second time of the order of 10 to the power minus 8 second time, it is releasing so much of energy. They showed pattern of energies. It released so much, electron release so much of energy that it should meet the nucleus if it is revolving around the nucleus. Bohr said, you are right. Electron is releasing energy and so much of energy, and yes, you are absolutely correct. In 10 raised to the power minus 8 second time, it releases so much of energy which is its own energy, but it is not wasting or spending that money from his pocket. Electron is not selling his land, or electron is not selling its land, not he. Electron is not selling its land and going to abroad for trips. That way, electron is killing its own money, and then electron will become poor. Let me tell you what I'm saying. See, Bohr said Rutherford is absolutely right. All the mass is concentrated in a very small volume called nucleus, and electrons are revolving around that nucleus. But during those revolution, electron have various orbits to revolve. The first orbit Rutherford named, this is orbit number 1. The second orbit is obviously 2. This is 3. This is 4. Rutherford also, Bohr also give this orbit a name called shell or stationary state, in which also he marked this shell as the first shell was K shell, L, M, and you all know this since class 9th, 10th. Now, the other name that I'm giving you, first shell is also known as ground state, because Bohr theory is only valid for single electron species. Whatever mathematics we are dealing over here is only valid for single electron species. The Bohr does not have any information for multi-electron species. So that is again a limitation of Bohr model. But for single electron species, Bohr said this is the case. So what are single electron species? You can have as many number of protons, but electron should be one inside you. Like Bohr theory is valid for whom then? For hydrogen. For He plus, proton 2, but He plus have one electron. For Li plus 2. So example, all these elements who have, after losing electron, if you have one electron, Bohr theory will apply to you. So Bohr said first orbit, now we will term first orbit as ground state. What will be second orbit? First excited state. Third orbit, second excited. Ground state is n equal to 1. I'm writing it. Orbit number 1 is known as ground state. Remember this, students forget this during exam. N equal to 2 is first excited state. N equal to 3 is second excited state. That's why I've written. N equal to 4, one last time. Third excited state. So on. So Bohr said, Maxwell, you are 100% correct. Electron is releasing energy, but not at its own cost. Bohr then used the photoelectric effect and black body radiation and particle nature of electron and said, see, there is one electron revolving in its ground state in its hometown. It is taking trips outside. It is taking lot of abroad trips, but not with its own money. It is receiving money from outside radiation. From outside radiation, this electron is accepting energy like a black body, like photoelectric effect. Energy coming, I am accepting that energy. And whatever energy I have accepted, I will jump into a higher orbit to spend that extra amount of energy. It's like, I am not going for a Europe trip by my own money. Maybe I received some money from Kaun Banega Crorepati. I win that show. I win a prize money. With that amount of money, now if I won, let's say 10 lakh rupees, so I will go to that state. I'll go to 4th orbit, 5th orbit, because I have a lot of money to spend, but not my money. I have not sold my car. I have not sold my land to take that abroad trip. This energy was not mine. Whatever energy I had, I still have that energy. That 100 rupees I'm taking, because I've got 100 rupees, so I'll go to 4th energy state, for example. I will revolve in that 4th state, spend that extra amount of money, and I'll again come back to my ground state. Bohr also proved this, that the time electron accepting energy, going to higher energy excited state, revolving and spending that extra amount and coming back to its ground state. The time required for all this transition was of the order of 10 raised to power minus 8 seconds. That means electron is releasing energy packets, but those energy packets electron is not releasing on its own cost. Whatever energy it has, it still has that energy. Hello? So this is how Bohr theory proved that Rutherford model was correct. Bohr didn't say this just like that. Bohr given mathematical proofs also. Now, what are those mathematical postulates, proposals which Bohr gave? The first mathematical postulate Bohr gave was, the first Bohr's postulate is, if electron is revolving and taking energy from outside radiation and going to any excited state and coming back to its ground state, all this action is happening because some incident energy I have accepted. So let's say this initial state is N1, this final state is N2. I can go to any excited state. If I win 10,000 rupees from Kaun Banega Crorepati, I will only go to Domino's next door. I cannot go to Europe. So What if I receive a higher packet, I'll go to higher orbit. If I receive low packet, I'll go to low packet, but I will never do this transition at my cost. So Planck's theory is also applied, that energy packet E is equal to incident energy is equal to hc upon lambda I or h nu I. So whatever incident energy is coming is doing what? This difference of energy. The energy between these two states, energy of N2 minus energy of N1, or simply the difference in energy of orbits which the electron has made a transition to and from will be equal to the value of incident. What is basic maths? So what is Bohr's first postulate? Delta E is equal to h nu I or hc upon lambda I. What is that I? I represents the value of incident radiation. What is Bohr's second postulate? And basically the most important postulate. Sir, you have made these orbits. We know atom, such a small species. Is it a Dahmer road? It is a concrete road that you can see and draw a measuring scale and you can measure the radius. Sir, it is not some concrete road. How can you say this is first orbit, this is second orbit? Bohr given that postulate also. Bohr said that distance from nucleus can only be defined as an orbit where the angular momentum of electron, if I'm moving in a single line, my momentum is mv, linear momentum. But if I'm revolving around a circle, my momentum will be termed as angular momentum. Bohr proved and postulated this, that only that distance from nucleus can be defined as an orbit where the angular momentum of revolving electron is quantized. Remember, quantized? Certain specific values are known, all the values are not known. So what is the quantized factor? It was h upon 2 pi. It was h upon 2 pi. It was h upon 2 pi. So h upon 2 pi. So first orbit, what distance can be said or defined as first orbit, where angular momentum will be h upon 2 pi. What distance can be termed as second orbit, whose angular momentum will be 2h upon 2 pi. What distance can be fifth orbit, where angular momentum can be 5 times of h upon 2 pi. So multiple of h upon 2 pi can only be obtained. In between values are not obtained. Like Indian currency is quantized. You can have 1 rupee note, 1 rupee coin, 2 rupee coin, 3 rupee coin does not exist. So Indian currency is quantized. You cannot have all the values in between. 1 you have, 2 you have, then 5 you have. Between 2 and 5 you do not have any currency. There is no 3 rupee note. There is no 3 value of the currency. So here multiple is h upon 2 pi. So what times of h upon 2 pi? Sir, n times of h upon 2 pi. What is formula of angular momentum? Sir, mvr. This you know through circular motion. If you do not know, I am telling you. What is the formula of angular momentum? mvr. So second postulate becomes mvr is equal to nh upon 2 pi, where m is mass of electron, v is velocity of electron in nth orbit, r is radius of nth orbit, n is orbit number, h is Planck's constant, 2 is 2 and pi is pi 3.14 or 22/7. Sir, why you are telling us every detail about this? Because JEE loves it. The mathematical postulates or formulas of Bohr model is tremendously loved by JEE. Moving ahead. Bohr didn't stop here. Bohr even gave you mathematical modeling to calculate that radius of stationary state. Those orbits are also called stationary state. Sir, how? I'm giving you derivation also, but for mains, I'm telling you, you should, by heart, you should learn the conclusion which we'll be getting. So, if this is nucleus and electron is revolving around the nucleus, and mind you, Bohr theory is only applied for single electron species. So, this is electron revolving and this is nucleus. Let's say nucleus has Z protons, so charge on protons would be Ze. So internal charge will be Ze, outer charge would be E, just like gravitational system. We know what is the force acting inside Coulombic force of attraction. If this radius between nucleus and the first orbit is fixed, let's say it is R, it may be first orbit, it may be second orbit, it may be third orbit, whatever orbit it is, the radius is R. And if I'm performing a circular motion, then one circular motion theory has to be logic has to be like what? Centripetal force will be equal to centrifugal force. That's why this radius is fixed throughout. What is the force acting this side? Sir, Coulombic force of attraction. Can you tell me what is Coulombic force of attraction? Sir, it is equal to K Q1 Q2 upon distance square. What is the force acting outside? Sir, centrifugal force. Can you tell me from rotational motion what is the formula of centrifugal force? Sir, it is equal to mv square by r. Those who do not know it, please learn. So Coulombic force is equal to centrifugal force, which is mv square by r. Simplify this. This r and this r get cancelled. So because I want to calculate r first, so r going there, taking on LHS side, K. What is charge Q1? It is Ze. What is this charge? E. So Ze square upon mass into velocity square. This is equation 1. Sir, now what? Bohr's second postulate. Remember? What is it? Sir, through second postulate, we know MVR is equal to NH upon 2 pi. So can you find out V from this equation? Yes, sir. So V is equal to NH upon 2 pi MR equation 2. Use equation 2 in equation 1. Okay, sir. Therefore, R is equal to K times Z square upon M into V square. This is V, square it, I'm squaring it. It is N square H square upon will go to the numerator 4 pi square M square R square. So I just have R now. Simplifying, this R and this R got cancelled. This M got cancelled. This nothing else is getting cancelled. So I am focusing on this R. So this R is equal to, bring everything over here, N square into H square upon Z, then K, then E square, then 4, then pi square, then M. Sir, you have done something. Yes. Constants I have recollected together, whereas variables I have not. Constants I have recollected together and variable I have not. So what is the formula of R you got? Sir, R is equal to N square upon Z into some constant. If you put the value of H 6.626 into 10 to the power minus 34, K, E square K is 1 upon 4 pi epsilon naught, E square 4 pi square M. If you put all these values, you can have that constant. What is M? Mass of electron. Pi you know, 4 you know. What is E? 1.6 into 10 to the power minus 19 coulomb. So if you know all these values, oh, K in CGS system, perfect. In CGS system, value of K is 1. Convert in SI. Sir, we do not have to do this. You just tell us that constant. Its value is 0.529 angstrom. So in short, I am giving you the final formula which you should learn by heart. Radius of nth orbit is equal to r naught into n square upon z. And the value of this r naught is, in terms of constant, it is this, and its actual value is 0.529. I'm giving you till 3 places of decimal, angstrom. Remember again, 1 angstrom is equal to 10 raised to the power minus 10 meters. So this is radius of nth orbit. Sir, if I know radius of nth orbit, can I calculate velocity of nth orbit? Yes. How? You remember this form? Sir, V I know. V is equal to nh upon 2 pi mr. N is the variable. I need h constant, 2 constant, pi constant, m mass of electron constant. If r, this is used, is everything a constant? Yes, except this n square and z. So I'm directly using this form. What is this form? nh upon 2 pi mr. So we know velocity is equal to nh upon 2 pi mr. Replacing this r with r naught into n square upon z will go to the numerator. Again, recollecting constants and variables. So velocity of nth orbit will be, what are the variables? Sir, this n and this n will get cancelled. So in numerator, I'm left with z. In denominator, I'm left with n. R naught is a constant. M, pi, 2 and h are constant. They will form a new constant. Let us name it V naught into. Multiplier would be z upon n. Very important. What is the value of this constant, sir? The value of V naught is 2.18 into 10 raised to the power 6 meter per second. Sir, we have calculated radius also. We have calculated velocity also. Bohr also calculated the energy of nth orbit. Didn't leave that also. Sir, how calculated? This is just the gravitation derivation which Bohr did. You must have did this derivation in 11th gravitational system. You know what is the total energy of any system, sir? It is equal to kinetic energy of that system plus potential energy of that system. So if I have to calculate total energy of any orbit, let's say total energy of nth orbit I'm representing as En, total energy of any nth orbit, first, second, third, fourth, any nth orbit. So what will be its kinetic energy? Sir, kinetic energy, electron will be revolving. So half mv square plus, what is potential energy, sir? Potential energy between two charges. What is its formula? Sir, K Q1 Q2 upon R, you told us. So K Q1, charge of nucleus is plus ZE. Acha, in potential energy, charges are always placed with their sign. While calculating force, that Q1, Q2, because force is a scalar quantity, we have assumed the direction that it is acting this side, that one centrifugal is acting outside. But energy is a scalar quantity, so you have to put charge with sign. This you know through physics also. So K ZE, which is charge of nucleus, into minus E, charge of electron, upon what is the distance? R. So this is the potential energy, this is the kinetic energy. Sir, potential energy, kinetic energy, though it is okay. So can you tell us what is energy of nth orbit? Yes, I can tell you. Half mv square minus k into ze square by r. This I am marking as equation 1. Now, sir, this is not appearing beautiful to us. Again, I said Bohr's second postulate is very important. You tell me what is that postulate? Sir, we remember that the postulate says mvr is equal to nh upon 2 pi. Can you see V over here? Can you see V over here? Yes, sir. So, using that Bohr postulate, the second postulate, mvr is equal to nh upon 2 pi, and using the common sense, what was the force acting outside? Centrifugal force, mv square. This mv square. So what is the centrifugal force? We know this through Bohr's model. And we also know one thing from Bohr's model, which is outside force, centrifugal force is mv square by r. Internally, what was acting? Sir, Coulombic force of attraction. What was it? K, Q1, Q2. Now this is force. Direction I have thought. K, Q1, Q2 upon R square. This R and this R will get cancelled. Can you see? Value of mv square, R is gone, is K ZE square by R. So can you replace this? Acha, this is not required as of now for derivation, but again a very important conclusion, but not required over here. So in equation 1, I can replace this mv square by K ZE square by R. So actually, I just want you to know the derivation. Do not learn it by heart, learn the conclusions. Now, replacing this mv square from equation 1, I can say energy of nth orbit is equal to half of mv square. So half of this value. So K ZE square upon R, but with that half it becomes 2R. And what is this? Minus K ZE square upon R. Minus K ZE square upon R. Sir, do the math. Sir, it is very easy. If this value I am taking as A, so this is also A, sir. So you tell me, what is energy of nth orbit? Sir, A by 2 minus A, that is minus A by 2. So this is the energy of nth orbit, which is minus K ZE square upon R. Not looking beautiful, but there is a very good conclusion which is even valid for gravitational body. Can you look at the value of total energy? Yes. Can you also look at the value of potential energy? Yes. So can I say, very important conclusion I am writing, even valid for gravitational system. Can I say this total energy, this can also be termed as total energy, how it is related to potential energy? Sir, total energy is equal to half of potential energy. Just check. This is potential energy, A by 2. So total energy is half of potential energy. Very important conclusion. The only important conclusion in this slide. Total energy of any body, gravitational body, and for electron also, it is equal to half of potential energy. Can you relate kinetic energy and potential energy? Yes, sir. Where is kinetic energy? Kinetic mv square is this. So kinetic energy is half of this. So that means this is kinetic energy. Kinetic energy is K ZE square upon 2R. Total energy is also K ZE square upon 2R, but sign is opposite. So can you tell me what is the relationship between total energy and kinetic energy? Sir, they are equal, just negative of each other. So very important conclusion, the only important conclusion in this slide. Now, one thing I have not covered. If you know the energy relationship, sir, you have not given us the formula, but like radius and velocity. I'm sorry, that's why I've taken one more slide. So what is energy of nth orbit? Sir, this I know. K is a constant, E square is a constant, 2 is a constant, radius R0 into R0 is a constant into n square upon z. So I'm taking this minus K ZE square upon 2R. Work on this. Minus K ZE square upon 2, and instead of R, I'm again writing R0 into n square upon z will go to numerator z, and z becomes z square. So energy of nth orbit minus, I'm again just focusing on the variable z and n. People forget that radius has n square upon z, velocity has z upon n, energy has Sir, Z square upon N square. Two constant, R naught constant, K constant, E square constant. This is not X, this is nothing. Hai na? So after solving all these constants, I am writing a new constant which is E naught, and again I have calculated this E naught for you. The value of E naught is, the value of this constant is 2.18 into 10 raised to the power minus 18 in joule, or 13.6 electron volt for per electron. For per electron, if I have a single electron species, so for per atom, what is the value of E naught? 2.18 into 10 to the power minus 18 joule, or 13.6 electron volts. So Bohr also calculated the energy of nth orbit. These formula you have to learn religiously, very important. Now, frequency or number of revolutions per second. Bohr, although whatever we have studied, we can do this using Bohr. I told you, second postulate over there, very important. Over there it was not used, now I'm using it. How? Just see. Sir, frequency, I know it is reciprocal of time period. From 9-10 standard, you know, time is equal to distance traveled upon the speed with which you are traveling that distance. Time, speed is equal to distance upon time, so time is equal to distance upon speed. It goes to the numerator because I am talking of frequency right now. Because we know the proportionality of radius, we know the proportionality of velocity of electron, we know the proportionality of energy of electron. I need to know the proportionality of frequency and time period. So whatever frequency, time period will be opposite. So frequency is generally asked now. So distance upon speed. Sir, what is the speed of electron when it is revolving? Sir, we already know it is Vn. So what is the distance electron travel when you are doing a circle? What distance you cover? Circumference of the circle. What is circumference of the circle? 2 pi Rn. Sir, again 2 pi is constant. So leave constants, because here constant you do not have to know. You just have to know the proportionality with the variables of Z and N. So, or I can say frequency of electron revolving in a Bohr orbit is proportional to velocity. V naught constant gone. R naught gone. 2 pi gone. Proportionality sign, because I just need those variables. You tell me what is the proportionality of Z and N for velocity. Sir, it is equal to Z upon N. Upon. What is the proportionality of R in terms of N and Z? Sir, it is equal to N square upon Z. Rearrange. You can clearly see Z comes to the numerator, so it becomes Z cube, sorry, Z square upon N cube. This is the proportionality for frequency using Bohr's model. Very important conclusion. For time period, reverse of it. Questions are directly asked. See, I'm covering everything, but those small questions, I'll be taking few, but those, because we have to optimize time. Remember, this is not going to be a 10 hours of atomic structure study. Although if given, but it is not good investment for you. You should practice so that calculation will also improve, and I am covering everything where mains can ask their questions. Moving ahead. Wavelength for any particular transition. Sir, Bohr has done this much. Bohr has done something else also. Yes. Bohr even calculated the wavelength for any transition. Like, I am an electron revolving in an orbit, let's say N1. I received energy from outside, made a transition to higher energy level. Sir, why I have made that transition? Because I have received this wavelength. So, Bohr's first postulate. What is energy incoming? Sir, it is equal to hc upon lambda, that is incoming, lambda I. Because of this, what I am doing, I am making a transition from N2 to N1, because change is always final minus initial. Finally, I am going to N2. My initial state was N1. So En2 minus En1, final minus initial is always change delta E. Can you tell me what is the formula of energy of nth orbit? Sir, we have already derived. So I can say hc upon this lambda is the wavelength. which has been received from the incident radiation, and because it has been released, I have made a transition. Hello? Okay. So if I'm releasing energy also, if I'm releasing any wavelength also, I'll come from some level to down level. So even if I'm taking that energy, I'm going up. I'm giving back that energy, I'm coming down, down as in to lower energy level, to ground states. But the associated wavelength will be same. If I'm taking 100 rupees, I'll go from 1 to 10. If I'm giving that 100 rupees, I'm coming from 10 to 1. Packet of that 100 rupee will remain the same. So value of that lambda will remain the same. If I'm accepting that lambda, going from up to down. If I'm releasing that lambda, coming from down to up. The transition lambda can also be related to this N1 and N2. How? I'm telling you. What is energy of E2? Minus E0 into Z square upon N2 square. Minus E0, okay, minus will become plus. Z square upon N1 square. You can clearly see the formula. So, or I can say 1 upon lambda. Sir, where HC has gone? Over there, because constant. E0 constant. These constants was also formulated by a scientist and hence given name Rydberg's constant and represented as R. So R times of Z square will come out whole into, this becomes positive. So 1 upon N1 square minus 1 upon N2 square. So the general derivation which we have done right now gives you the wavelength associated to any transaction, and I'm telling you this. If I'm going from 1 to 4, I'm taking this lambda. If I'm coming from 4 to 1, I'm giving back that lambda. Value of lambda will remain the same. My point is, even if in question you are asked, an electron is transiting from 1 to 4 or from 4 to 1, do not worry. Put N1 as the smaller orbit, put N2 as the larger orbit, because lambda can never be negative. So if electron is moving from 1 to 4 or 4 to 1, it does not impact while calculating lambda. You put N1 should always be less than N2. So from 4 to 1 or 1 to 4, whatever question has given, initial orbit may be 1, initial orbit may be 4. When I use this formula to calculate lambda, I will put N1 the smaller value, N2 the larger value. Mathematically you can understand that's why lambda will be, that's how lambda can be positive. Moving ahead, now by using these transitions, Bohr also formulated hydrogen spectrum. What is the spectrum? Whenever an atom gives energy or receives energy, it forms a forms a pattern on photographic plate. If it is a visible radiation, you can see that pattern. If it is not a visible radiation, there are methods called, there are apparatus called spectroscopy. Through spectroscopy, you can observe every electromagnetic radiation belonging to any range. Visible range you can see, but if the range is not visible, those patterns can also be observed, and those patterns are called spectrum. Now, if I'm understanding and observing electron transition of hydrogen, so that spectrum will be termed as hydrogen spectrum. So studying the hydrogen spectrum, that is for single electron species, Bohr and not Bohr, other scientists including Bohr observed that whenever electron make a transition from higher state to n equal to 1, the ground state, from higher state to n equal to 1, the ground state, all the spectral lines lie on the broad spectrum. In which region? They were lying on ultraviolet region. Whenever, because energy difference is higher. So whenever electrons are making a transition from higher state to n equal to 1, whenever electrons are making a transition from higher state to n equal to 1, all these spectral lines were named as Lyman series. Why? Because all these spectral lines, the range of all these spectral lines were lying on ultraviolet region. Although I've given the value of wavelength also. You do not have to learn them. For physics, you must be needing them, but for chemistry, these values are not generally asked. So whenever in hydrogen or single electron species, specifically for hydrogen, if electron make a transition from higher state to n equal to 1, all the spectral lines, all the electromagnetic radiations released are called Lyman series lines. Similarly, from higher state to n equal to 2, if the electron is making a transition from higher state to n equal to 1 is Lyman series, from higher state to n equal to 2 is Balmer series. I have read it like I have learned it like a rhyme. Lyman, Balmer, Paschen, bracket, Fund. Fund starts with P, by the way. Lyman, Balmer, Paschen, bracket, Fund. Although for 6 it's Humphrey, but not generally used. Lyman, Balmer, Paschen, bracket, Fund and Humphrey. What are these spectral lines? When electron at higher energy level will obviously lose energy and go to lower energy level. If it is going to n equal to 1, spectral lines are Lyman series lines. If from higher it is going to 2, Balmer series. From higher to n equal to 3, Paschen. From higher to n equal to 4, bracket. From higher to n equal to 5, Fund series. From higher to n equal to 6, Humphrey series. Now, in which range they lie, you should remember that also. Lyman spectral lines lie on ultraviolet region, on the broad spectrum. Balmer lie on visible spectrum. You can see those line, Balmer series line. Paschen, bracket, Fund all lies in infrared. And obviously after that also, all these spectral lines lie in which range of broad spectrum? Remember, cosmic to radio waves. Which region they lie? They lie in infrared region. Now, because you know Balmer series lie in the visible range, so visible range is VIBGYOR, VIBGYOR, because you can see that. Sir, but why this spectral lines are drawn in such a way? Because we have just calculated the value of energy over here. What was the value of energy we calculated? En is equal to minus E naught into n square by z. You just do one thing, and I would recommend, I highly recommend you learn these values. So for hydrogen you have to learn them. So for hydrogen, can you tell me what is the value of E1? Very easy, sir. Minus, for hydrogen, Z will definitely be 1. So Z is 1, gone. So when n is 1, so what is value of first or energy of first orbit of hydrogen? Minus 13.6 electron volt. Learn it. So what is the value of second orbit of hydrogen, sir? Minus 13.6 upon 4. It comes out to be minus 3.4 electron volt. 13.6 upon 2 square is 4. E3 is minus 13.6 upon 3 square is 9. So it comes out to be 1.51 electron volt. What is fourth orbit? Minus 13.6 upon 4 square is 16. This is 0.85 electron volt. Then E5, minus 13.6 upon 5 square is 25, 0.54 electron volt. My dear friends, okay, I'm sorry, minus. Okay. Learn these values, very important, very important for the case of mathematical ease. They will help you like anything. So these are the energies of the 5 orbits of hydrogen. If for other element you have to know nothing, there will be multiplication with z square, because z is 1 for hydrogen. So z square for, let's say, for any element, you know it's z, multiply these value by z square, but learn these for hydrogen. Now you tell me, if I draw this energy on a number line, what is the energy of an orbit which is at a distance of infinity from hydrogen? That's easy. For n, we write infinity, infinity square. Anything upon infinity approaches 0 electron volt. That means if you plot this energy on xy plane, where y-axis represents the energy, x-axis will have E energy equal to 0. So x-axis will be your E infinity, that is nth orbit energy. What will be the energy of first orbit? Sir, minus 13.6. So if this is x-axis, minus 13.6 will be over there, let's say. What is energy of second orbit? Sir, minus 3.4. You can check what is the difference. Sir, 10.2. And after that, the difference is getting very much reduced. The energy difference is highest over here, and after this, the difference is getting reduced. In fact, over here, the difference is almost negligible. That's why, while drawing hydrogen spectrum, you have seen this picture. So this is energy of first orbit. So what is this value? Sir, minus 13.6 electron volt is for all of them. I'm just writing the value. What is energy of second orbit? Sir, minus 3.4. What is energy of third orbit? Sir, minus 1.54. Fourth orbit, sir, minus 0.85. Now, even I am not having a space to write because this last line will be what? Will be n equal to infinity, where E infinity has a value of 0. You got my point. So where is the energy difference highest? This. So after drawing this photo on a number line mathematically, statistically, I can easily say, sir, if this is difference in energy, so for traveling this much difference of energy, associated frequency will be directly proportional, because energy is directly proportional to, remember, delta is equal to h nu or hc by lambda. So h nu or hc by lambda. So difference in energy is directly proportional to frequency and inversely proportional to wavelength. What I'm saying is, this difference is highest and this difference is decreasing and getting smaller and smaller. So why I have written in this format? So that by just doing this is more and this is less. If energy difference is more, associated frequency is more and associated wavelength is minimum. Hello? We will discuss some Lyman-Balmer-Paschen examples according to this, but finishing first this Balmer series with you. Now you tell me, after knowing this, which transition of Balmer series would be red? Why asking red, sir? What is visible range, my friends? It is VIBGYOR. Remember the broad spectrum. In this direction, what was increasing? Frequency. In this direction, what was increasing? Wavelength. For Balmer series is higher to n equal to 2. You tell me which has the minimum energy difference. Sir, you have to reach till 2. You have to jump from higher orbit. So this, let's say this is infinity to this is large. 3 to 2 is small. So which energy difference is small? 3 to 2. The smallest energy difference is minimum. So associated wavelength will be maximum. And in VIBGYOR, in this direction, wavelength increases. So maximum wavelength is of red color. So red will be the color for the transition of 3 to 2. See, red color. This is the picture from NCERT. 3 to 2. From somewhere else. From 3 to 2. Then if this is 3 to 2, the remaining difference you have to learn that this is blue. But red you can definitely say it is from 3 to 2 because red has the maximum wavelength. And because red has the maximum wavelength, so energy difference should be minimum. Moving ahead. Now, at least I can sip water and you can read the question and try to solve it. So this question from JEE Main 2019 is asking you the difference between, sir, this symbol we have given to wave number, mu bar. Sir, but here, although this is how the question tricks you, although you would not get tricked also if you would have missed it, because it is saying delta nu is difference between nu max minus nu minimum. And what is this? It is defining it. It is difference in maxima and minima frequency, not wave number, frequency. So you have to calculate this delta nu for Lyman and Balmer series. Again, we have just completed this Lyman and Balmer series. So what is Lyman series? Sir, for Lyman series, we definitely already seen, and now we know electron makes a transition from higher state to n equal to 1. So in order to have nu max, although frequency we write nu, but the question has designed it to confuse the student as wave number nu bar, but it is frequency. So this maximum frequency, sir, frequency is proportional to energy. So if energy is maximum, frequency is maximum and wavelength minimum, but I have to calculate maximum frequency. So for n equal to 1, what will be the maximum energy transition from infinity to 1? So this will be from infinity to 1. You remember what is the formula of wavelength, sir? 1 upon lambda is equal to r into z square into 1 upon n1 square minus 1 upon n2 square. Okay, this value of r, I guess, over there, yes, this value of r, the Rydberg's constant, what is its value? Its exact value is 1.097. Leave it, because for calculations this much value will do. So r you have to put to be 1.1 into 10 raised to the power 7, and the unit will be meter inverse. Why? Because everything is dimensionless over here. Only wavelength will have a unit, and that is meters. So it is per meter. Coming to the question that we were discussing, although unit of a value of r will not be used in this question. So what I'm saying is, sir, but we do not have to calculate wavelength. We have to calculate frequency. My dear friends, you know nu is equal to c by lambda. So ultimately, nu, which is frequency, is proportional to wavelength, and this wavelength is proportional to r is constant. Z, I guess it is talking of hydrogen. So Z will be 1. So that you can skip that also. So we are left with only this difference part. That is 1 upon n1 square minus 1 upon n2 square. So you just have to focus on that part. Okay. Focusing on that part over here. So this lambda nu max will be proportional to what? Sir, maximum for Lyman. For Lyman, maximum is infinity to 1. So 1 upon 1 square minus 1 upon infinity square. Anything upon infinity 0. So this is nothing but 1. So what will be nu bar, which is frequency for the minimum energy transition? Sir, for Lyman series, minimum is from 2 to 1. Minimum 2 to 1. So what will be this block over here? So 1 upon 1 square minus 1 upon 2 square is 4. Calculated, this proportionality will come out to be 3 by 4. What I have to calculate? I have to calculate this delta nu for Lyman series. What is delta nu? Max minus minimum. So delta nu for Lyman will be proportional to max, which is 1, minus minimum, which is 3 by 4. So this will come out to be 4 minus 3, 1 by 4. This is the delta nu for Lyman series. Doing it again for Balmer series. So delta nu bar for Balmer will again be what? It will be proportional to delta nu max for Balmer minus delta nu minimum for Balmer. Sir, for Balmer, what will be the maximum energy transition? I'm directly doing the proportionality here. For Balmer, Balmer is from higher to n equal to 2. So what will be maximum? Infinity to 2. So 1 upon 2 square is 4 minus 1 upon infinity square is 0. But I'm writing it just because this is max minus. For minimum, so for minimum energy, minimum frequency, minimum energy difference. So 3 to 2. So 1 upon 2 square minus 1 upon 3 square is 9. So calculating it for you, this is nothing but 1 by 4 minus 9 minus 4 is 5. 9 into 4 is 36. So this proportionality will come out to be 36 will be taken as LCM. So this will be 9 minus 5. So this proportionality will be 4 upon 36 or simply 1:9. So I guess what was the maximum for Lyman delta nu was 1 by 4. Okay. For Balmer it is 1 by 9. So delta nu for Lyman upon delta nu for Balmer is equal to what? 1 by 4 upon 1 by 9. So your answer will be 9 by 4. Do we have any option? Yes, option 1. Bingo. Moving ahead. Again, a JEE question and the same analogy is asked. I'm intentionally making the same question so that this concept, the maximum minimum concept, is very famous for JEE. Do it. Number is your achievement. The shortest wavelength over here, you have to calculate shortest wavelength of hydrogen atom in Lyman series is lambda. Shortest wavelength as in maximum energy, maximum frequency, wavelength, minimum, shortest. So for shortest wavelength as in maximum energy for Lyman series. So for Lyman series, maximum energy difference will be from infinity to 1. This wavelength is lambda. So 1 upon lambda is equal to R into hydrogen. What is Z square for hydrogen? 1 square. So this will be nothing but 1 upon 1 square minus anything upon infinity is 0. So this is nothing but R. So this is lambda. The longest now, okay. Now for the question, you have to find out the longest wavelength. If wavelength is longest, energy difference will be minimum. Energy difference minimum, so frequency will be energy minimum, frequency minimum. So longest wavelength has a minimum energy difference. Balmer series is higher to n equal to 2. So minimum, in order to reach 2, I have to be in 3. So this is 3 to 2 transition for HE plus. We have to calculate wavelength. So let's say this wavelength is lambda dash. I do not know this wavelength. This is equal to R. R is what? 1 upon lambda, because you have to give answer in terms of lambda. 1 upon N1 will always be the smaller number. So 1 upon 2 square is 4 minus 1 upon 3 square is 9. So 1 upon lambda dash came out to be 1 upon lambda into 36 and numerator is 5. You have to calculate this lambda dash. So lambda dash will be equal to 36 into lambda upon 5. Okay, we missed one thing. What? Sir, this you are writing for? This we are writing for helium plus. Keep your mind, hand, everything open and very sharp. Do not miss it. R into Z square. What is Z for helium? For hydrogen it is 1. But for other single electron species, if it is not 1, you have to put it. For helium, Z is 2. So 2 square becomes 4. So a 4 will be multiplied with this. When 4 will be multiplied with this, obviously that 4 will be coming over here. So this 4, 9 is 36. So this is 9. So your answer is 9 lambda upon 5. Look at the beauty of JEE. Whoever misses that Z will take option A, because option A is what we have done initially. So answer is 9 lambda by 5, that is option C. Moving ahead. Next question says radius of second orbit. Next question says radius of second orbit of Li plus 2 is x. Okay, sir. The expected radius. Okay, first we'll use the take the formula of radius. So what is the formula of radius? Radius of second orbit, which you have to take as x. The formula is r0 into n square upon z. What is n? Second orbit. N square becomes 2, because 2 square is 4. n square upon z. What is z for lithium? 3, sir. So this is my equation 1 where I have got x in form of r0 and r0. The expected radius for third orbit. So you have to calculate r3, but you have to calculate this r3 for whom? For BE plus 3. Formula will be r0. Instead of r0, what do you write? 3x by 4, because options are all present in form of x. You have to replace r0. So r0 into n square, third orbit, 3 square is 9 upon z. What is atomic number of beryllium? 4, sir. So the answer is 9 into 3 is 27, 4 into 4 is 16, 27x upon 16, option D. Moving ahead. Next question says, again it is talking of radius, so let's do it. I mean, third Bohr orbit of hydrogen is R3. So R3, what is R3? Sir, R0 into 3 square is 9. Whenever you know a concept, things become a piece of cake for you. That piece of cake I was talking about initially. So you have to calculate radius of fourth orbit, that is R4. So R4 will be what, sir? R4 will be R0, but R0 I am placing in form of R3 by 9 because options are there as R3 by 9. So instead of R0, I have used R3 by 9. So radius is R0 into n square. What is n? 4. 4 square is 16. So 16 upon Z. It is talking of hydrogen only. So 1. So what is your answer? 16 R3 by 9. You have 16 R3 by 9. Yes, sir. Option B. Moving ahead. Next, okay. Now this is a question from NCERT. Whatever we have done, the same logic is applied. But this is a question from NCERT and I have to tell you the beauty of this question as well. This actually is a topic which is equi-energy transition. I'm explaining what it is. NCERT is a very beautiful book. With minimum resource, it gives you such a good knowledge that to decode that knowledge, you need some mentors. There's the game. So the transition in hydrogen spectrum would have the same, what transition in hydrogen spectrum would have the same wavelength as the Balmer transition from 4 to 2 of He plus 2. Okay. So for hydrogen, you have to calculate a transition. So for transition, what can we calculate very easily? Wavelength. So calculate that wavelength for hydrogen. So for hydrogen, that wavelength will be, I do not know, let's say it is lambda. So that wavelength will be R into 1 square for hydrogen, N1 square minus N2 square, because I do not know what transition in hydrogen will have the same wavelength. If wavelength if same, 1 upon lambda will also be same. So we have to equate this wavelength with whom? This wavelength should be same for He plus also. If wavelength will be same, 1 upon lambda will also be same. But for what transition of He plus? From 4 to 2. So for if you apply, lambda is same. So if you apply the formula of 1 upon lambda for helium, so it will also be equal to R into Z square. Z for helium is 2. So 2 square becomes 4. 1 upon N1 square, as in 2 square is 4 minus 1 upon 4 square is 16. So R will definitely get cancelled. So this is 1 upon N1 square minus 1 upon N2 square becomes, multiply 4. So this is 1 minus 1 upon 4. Now, sir, we have two unknown, but one equation. Do the observational maths. What is that, sir? Beta, if you do 1 square, what you'll get? 1. If you do 2 square, what you'll get? 4. So observational analytics is telling you something. Sir, N1 is 1, N2 is 2. So if electron is making a transition in hydrogen from 1 to 2, the wavelength will be same when that electron is now present in helium plus. And in helium plus, if it is making transition from 4 to 2, it will have the same wavelength as that of hydrogen when it is making a transition from 1 to 2. Now, with this observation, I'm giving you a trick, a very common sense actually, not a trick. Suppose, like helium, in the case of helium, there was a transition from 2 to 4 or 4 to 2. If you have to calculate what transition of hydrogen will have same wavelength, because energy difference will be same. We have just now calculated. What we have to do is, this transition was from 1 to 2. Just an observational maths I'm again asking you to do. Beta, if we divide, what is atomic number of helium? 2. If we divide 2, the atomic number of that particular element, with the state, whatever state you are getting will have the same wavelength. Example, if you divide 4 by 2, what are you getting? 2. So I am asking you to divide by atomic number. So 4 by 2 is 2, 2 by 2 is 1. So this can be applied. You just check, this can be applied everywhere. For example, if hydrogen is making a transition from 1 to 2, now you tell me what lithium plus 2 transaction will have the same wavelength. Sir, lithium has atomic number 3. So if I have to go from a heavy metal to a lighter metal, I am dividing. So if I have to go to a heavy metal from a lighter metal, I have to multiply that Z. So 2 into 3 becomes 6, and 1 into 3 becomes 3. So for He plus 2, a transition from 3 to 6 will have the same wavelength. But sometimes coming back may not be possible. Like, for example, if I'm asking you that in case of Li plus 2, a transaction is happening from, let's say, 8 to 3. Now you tell me whatever wavelength associated with it, equipartition, equi-energy, what hydrogen, in case of hydrogen, what transition will have same wavelength? So its atomic number is 3. You will divide 3 by 3, you will get 1. But if you will divide 8 by 3, will you get an integer? No. And we know energy level are quantized. So that 3 to 8 transition associated lambda, in case of hydrogen, you will not get. So going forward is always a case, but you will always do with respect to hydrogen. If some other element is given, you first reach hydrogen and then go ahead. These questions are not generally asked in JEE, but I feel it's a very good common sense logic using equi-energy transitions. Moving ahead. Now, the next question that is given to you says, find out wavelength of a photon. Okay, sir. During a transition, again the transition is from 4 to 2 in a single electron system. Okay. Bohr calculations only valid for single electron system, which has a ground level potential energy equal to this. Okay, so first potential energy is supplied of the ground state. Sir, we remember from the derivation, you check that slide, total energy, which is energy of nth orbit, is equal to half of potential energy. Remember? So potential energy is given out to be minus 108.8 electron volt divided by 2. You will be getting minus 54.4 electron volt. This is the energy of ground level, as in this is the value of E1. I do not know for what single electron species, but I know it's ground state energy. What is energy of ground state? Minus E naught into Z square upon N square, because 1, so it is 1, so removing. So what atom we are minus will become plus. So what atom we are talking of, sir? Z square is 54.4 upon E naught, which is 13.6. You can clearly see it is 4 times. So Z is what? Sir, Z is 2. So it has through the information of potential energy, it was actually supplying you the atomic number. So it is 2. That means the question is talking of helium plus. So now the question is, for helium plus, which was hidden, you have to find out wavelength during a transition from 4 to 2. Done so many times, sir. So for helium, this lambda will be equal to R into 2 square is 4 into 1 upon 2 square is 4 minus 1 upon 4 square is 16. Do the math. I have told you the value of R. Value of R is 1.1 into 10 raised to power 7. What the lambda that you will get, it will be in meters. Moving ahead. Okay. So the next question says, an electron, again a hydrogen-like species, during a transition from 4 to 2, oh my god, 4 to 2 transition again, emits a wavelength of 1216 angstrom. So this is value of lambda. Okay. So now you know lambda also, you know N1, N2 also, you already know. So again Z square is hidden. So 1 upon lambda, which is 1216, but it is angstrom. So SI unit is meter. So 10 to the power minus 10 meter is equal to R, which is 1.1 into 10 raised to the power 7 into Z square into 1 upon N1 square is 4 minus 1 upon N2 square is 16. You can find Z. Now you have to find out the potential energy of an electron. If you know Z, you have to, now again the reverse question. Now you have to find potential energy of third excited level. What is third excited level? Ground state is n equal to 1. First excited state is n equal to 2. So third will be add 1, n equal to 4. So you have to tell me the potential energy. Sir, if I have to calculate potential energy, I do not have formula. Beta, you have formula. Why? Potential energy is half, total energy is half of potential energy. So potential energy will be twice of total energy. Total energy of what? Total of third excited state, as in E4. So if you have to calculate 2E4, your value will be 2 into what will be the value of E4 minus E naught, which is 13.6 into Z square we have to find upon N square. 4 is 16. So this Z square is the only thing that is remaining. You do the math. I guess it will be easily solved because Z has to be an integer. So you'll find the closest integer, you'll approximate, and in these cases you can approximate as well. You'll definitely find the answer. Into divide is something which you should pay a huge amount of attention to. Moving ahead. Now some basic definitions. What is ionization? Because sometimes word problems uses these definitions and hides some data like Z, like N, like sometimes these data are hidden in these definitions. So you should know these definitions. What is ionization energy? Sir, if electron is present in ground state, you provide it energy so that it make a transition to n equal to infinity. So from ground state to infinity, whatever energy you provide, it's the ionization energy. So ionization energy in short is the energy difference. What is energy? Final minus initial. Final you have to reach where? E infinity. Initially you are present where? Sir, E1. Anything above infinity is 0. In E infinity is always 0. So minus, what is formula of E1? Minus E naught, so that minus minus becomes plus. So E naught into Z square upon N square. Sir, for N equal to 1, this will also be 1. So your basic formula is E naught into Z square is ionization energy of every single electron species. So for hydrogen, this value is 13.6. For He plus, it will be 2 square. That means 13.6 into 4. For Li plus 2, it will be 13.6 into 9. These values. In general, 13.6 Z square. Sir, what is ionization potential? The potential, remember, EV, electron volt. Sir, if this is 13.6 EV, remove E, whatever potential is left, that is the ionization potential. So, okay, I'm sorry, this will be 13.6. 13.6 will be the ionization. The associated potential is ionization potential. Moving ahead. Other definitions, what is excitation energy? Sometimes an electron from one level is not made a transition to infinity. It makes a transition to, let's say, the high energy level. So that energy will be excitation energy. So it is the minimum energy required to move an electron from ground state to any excited state, not till infinity, to any. That will be the excitation energy. For example, what will be the fourth excitation energy of hydrogen? What will be the first excitation energy? From 1 to 2. Second excitation energy from 1 to 3. Third from 1 to 4. Fourth from 1 to 5. So actually you have to calculate E5 minus E1. You know the formula. So this difference will give you the excitation energy for hydrogen for fourth excitation energy. Now, what is binding or separation energy? Minimum energy required to remove an electron from any state to infinity. If electron is present in ground state, that energy is ionization energy. So yes, separation energy is a special case of ionization energy. But definition, theory, you should know. That's why I'm telling you. Moving ahead. Now, sir, these levels are quantized. You are saying from so many hours, minutes, actually not hours. How are we so confident about them? Because we have seen their atomic spectrums, their molecular spectrums. What, sir? Spectrum? Can you discuss something more about spectrum? Yes, I am. Spectrum is a result of spectroscopy. If you do that from white light, you can see it with your eyes on a photographic plate, the colors. And if not, so specific spectroscopy can also be used on these days from computer animation as well. Those electromagnetic radiation which you cannot see. So basically, I mean, I'm not going into that, that you'll be doing in your engineering. So basically for 11, 12 for JEE, spectrum there are basically of two types. They can be based on origin, they can be based on the nature, the pattern. First, I'll discuss on the basis of origin. Origin as in, if I am an excited sample, as in, let's say I'm hydrogen, I have an electron which is in, let's say, n equal to 6. So it's I'm an excited atom. My electron has gained energy from somewhere, from some source. So if I am an excited sample, that electron will make a transition. And when it will make a transition, it will throw packets. That packet of energy, when you are observing, how you observe? You channelize it through a slit, make it fall on a prism, and then you detect it in a photographic film. When you detect, the pattern that you observe on that photographic plate is termed as emission spectrum. Is termed as, because an excited sample is emitting out that electromagnetic radiation. Similarly, if I am an atom and I'm not excited, my electron is in my ground state. A source can give me energy. I can gain energy from outside environment. I have to gain energy from outside environment. A source is throwing energy on this ground state atom. It will absorb the energy and transmit the remaining electromagnetic radiations. I've absorbed some, I've cached some packets, and I've left some packets. So whatever packets I have left will be channelized through a slit and prism, observed on a photographic film or a detector. The pattern observed is now known as absorption spectrum. And this is directly from NCERT. If you observe the pattern, you can clearly see they are photographic negative of each other. As in, when no transition was found, it was showing transition. When it is black, it is colored. When it is colored, it is black. So this is types of spectrum on the basis of origin. Now, there are other types of spectrum which is on the basis of their pattern, on the basis of their nature, which is continuous and discrete. Discrete may be band also, discrete may be line also. First, look at this spectrum. This spectrum, when the electromagnetic radiations are forming a pattern, this pattern is almost continuous. So Some people say absorption spectrum is also a type of continuous spectrum. Similarly, some people say emission spectrum is also a type of line spectrum. Now, moving ahead. Okay, one more observation. Okay, I'll tell you that observation in the later slide. Moving ahead. For continuous spectrum. Technically, continuous spectrum is such a spectrum where all the colors are superimposing on each other. There is no empty gap. If there is a color pattern, there is no black empty space in the photograph. Such a pattern is a continuous pattern. What is a discrete pattern? It may be line, then dark spaces. It may be some thick color bands, but still it will have some dark spaces. So discrete is not continuous. Colors are separated. It may generally, who gives band spectrum? If you are giving so thick amount of electromagnetic radiations, you need more number of species. Who has more number of species? So generally, molecular spectrum is a band spectrum and atomic spectrum is a line spectrum, because atom has limited species involved with it. So they will catch and they'll throw, and that throw will just give one line. If group of people are there, they'll catch in group, they'll throw in group, a thick band will be formed. So these are some basics. Theoretically, they are good and important, I'm telling you. Moving ahead. Now more about spectrum. One thing which I have to tell you, it's also an observational thing. Can you tell me the angle of deviation? The angle of deviation, the white light is coming to the prism and getting deflected. So can you tell me angle of deviation of light is proportional to what? This is visible light. Visible light is Vibgyor. Can you see with your eyes, red is getting least deflected, while others, blue is clearly seen, yellow in between. Red is, when coming from this side, red is having minimum deflection and others are having maximum deflection. Who has minimum frequency and maximum wavelength? Red. So this angle of deviation is directly proportional to frequency of electromagnetic radiation. Those who have higher frequency, higher energy will deflect more. Now, this is also a very, actually a very common sense. Now, if wavelength decreases, spectral lines tends to converge. They approach each other. I'll show you. I mean, this is just a drawing. Suppose I have this wave. So what will be its wavelength? From one high to another high. This is another wave. Now, if wavelength is decreasing, wavelength decreased. You tell me, when wavelength is decreasing, is it not visible to you clearly that spectral lines are approaching each other, they are converging? And if wavelength is getting increased, can you see spectral lines are diverging? So this is a wave observational theory that you should know. Very generally, very not given in books, not taught, but very important. Moving ahead. Now, when these transitions were taking place, some questions related to spectral lines, number of different spectral lines are also asked. Like suppose I ask you that an electron is present in 5th orbit. Obviously, it will come to ground state. How many different types of spectral lines you can have? The formula, the direct formula in order to it is just a topic of probability. But for mains, remembering formula makes it easy, makes it faster. So if you have enough number of atoms should be enough, because in order to make different type of spectral lines, you need different number of atoms, which will make those different transitions. So if you have different number of atoms, and electron is making a transition from any high state n to ground state. It has to reach till ground state. Generally it reaches ground state, but if question is asking it is reaching ground state, then how many different spectral lines it can make? Answer is n into n minus 1 by 2. For example, if I'm making a transition from 5 to 2, how many spectral lines I can make? Answer is 5 into 5 minus 1 is 4 upon 2. So answer will be 10. How come 10? I'll make you count also. If I am standing on 5th floor, it is like this. If you have a enemy, you kick that enemy from 5th floor. How many ways you can kick that person till ground state? So first, if you are very frustrated, you will bring the person, give him a kick. Very violent example, by the way, not good, but it will fall to 4th. Maybe if you have kicked with much intensity, it has fallen to 3. Maybe much more, so 2. Maybe much more, 1. These are the 4 spectral lines. If you have kicked and he has reached to 4th floor, you will again go down the stairs, pick him up. From 4th floor, you will again kick. So from 4th floor, he may fall to 3. From 4th floor, he may fall to 2. From 4th floor, he may fall to 1. If fallen to 3rd floor, you will again go downstairs, 3, give a kick, 2, or from 3 it may go to 1. If it has gone to 2nd floor, you will again climb down the stairs, and from 3 you will kick him to 1. Sorry, you have gone to downstairs. From 2 you have reached downstairs, no? So from 2 you will kick, and there is only one possibility. Count these number of lines. Sir, 4, 3, 2, 1. So it's simple APGP. That's why we have formulated a direct result for you, which is n into n minus 1 by 2. 4, 3, 7, 7 and 3 are 10 different spectral lines are obtained. Now, but if an electron is making a transition from some higher state, not till ground state, till some state in between, like for example, this was the first question. If the questionnaire is asking you electron is making a transition from 5th, but it is not reaching 1, it is reaching till 2, then how many spectral lines? All the spectral lines below 2 you do not have to consider, because question is asking from 5 to 2 how many spectral lines you can get. Again, you can count also, but his number is higher, then counting will be bit difficult. So what is the formula for that? Formula is delta n into delta n plus 1 upon 2. What is delta n? Delta n is the difference in those energy levels, n2 minus n1. And if you have an isolated atom, only one atom you have, and that one atom, obviously it is a single electron species. If that only single electron species, that one atom is present, let's say in nth level, how many different spectra? Sir, now you have only one, no? So if you have to find maximum number of spectral lines, what you'll do? My example. Take that person, kick it, and try to kick it only till next level. Example, if so, just the formula. If you are kicking from nth level, maximum number of lines you can get is n minus 1. How? If I'm in 5th level, what is the maximum possibility? Sir, from 5 to 4, then I'll go to 4, again kick, then 3, again kick, then 2, again kick. That's it, because I do not have any other atom. If there is only one atom present in the system, what is the maximum number of spectral lines you can have? Sir, 4. So I have kicked from nth orbit, and the value I've got is maximum spectral line is n minus 1. So these are some questions which are famous in JEE. Moving ahead, Bohr theory completed. Now Bohr theory also have some limitation. The very first limitation, it is only valid for single electron system. Sir, we have multi-electron system in nature. How their atomic structure can be determined? So Bohr theory could not tell it. Although whatever Bohr theory has told us, it has made whatever derivations we have done, it is 2D derivation. That is, Bohr theory says it's a circular path. Circular path is a 2D path. And we all know we are all 3D people. So atom must also be a spherical atom, not a two-dimensional atom. So that is also a problem. Moving ahead, there's some theoretical thing. Bohr theory was unable to explain some observation done by some people at that point of time. The effects are called Zeeman and Stark effect. Whatever spectral lines we have seen, these spectral lines were splitting. They were breaking down, splitting into parts. When magnetic field applied, they were splitting. This was observed by Zeeman and hence known as Zeeman effect. Students forget this. So I give them a trick. What? If spectral lines are splitting in presence of external magnetic field is M, Z-man is M. So Z-man, spectral lines get split in presence of external magnetic field. And when spectral lines get split in presence of external electric field, that is called Stark effect. These effects were also not explained by Bohr. And whatever Bohr told us, that was also proved to be wrong by two different individuals. They are de Broglie. He gave an equation that devastated the Bohr theory. And Heisenberg, coupled up with de Broglie, wasted Bohr's theory. People started doubting whatever we have studied till now. They started doubting that also. Sir, how come these two people have made such accusations? That's why I've handwritten these de Broglie hypothesis, because this person started it. No, they are not bad people. Actually, they were the people who were the founding stone, founding people, founding minds, because of whom we now know the atomic structure, which is the quantum model. Moving ahead. De Broglie said, have you seen a fan in your room? People replied, yes. Said, okay. When fan is revolving, can you tell me what is the exact position of that fan at this instant? So at this instant, exact at this instant, can you tell me its exact position? No. Similarly, you must have seen movies, X-Men movies. When someone runs so fast, faster than speed of light, you cannot see the person, because how can you see the person? Light falls on that person and comes to your eye retina. The image gets into your mind, magnified through your eyes. This is the mechanism Mother Nature has given to us. So if a person is running faster than speed of light, you cannot see the person. That is the case of invisibility. Now, you tell me, de Broglie asked people, if a person is moving with velocity at the same point of time, if the mass of that person is very negligible, like you again go to that fan. When fan is moving, you see the motor, the single phase induction motor in between. That motor is always visible to you. But the fins of the fan, when they are moving, you cannot see them. So actually de Broglie said that matter has dual nature. De Broglie said, I agree. But he not only said, he proved and mathematically postulated that the dual nature every matter has, the wave nature of that matter, of every matter, is inversely proportional to its particle nature. The motor of the fan is very heavy. So even if it is moving, its particle nature, its mass nature is predominant. Therefore, even if it is moving, it is not actually a wave. You can actually see the fan motor even if it is moving. But the fins of the fan, whose mass is very less, when they are moving, their wave nature increases and their particle nature becomes negligible. So, de Broglie hypothesis is matter has dual nature, but both of their nature are inversely proportional, and one nature will be deciding your maximum properties. So both these nature are inversely proportional to each other. Sir, mathematically formulate this. Okay, I'm doing it. In order to estimate the wave nature, de Broglie took wavelength, and hence this wavelength is also called de Broglie's wavelength. And since it is inversely proportional to particle nature, so de Broglie used momentum as a characteristic of particle nature, and he mathematically, experimentally proved this, that wavelength is inversely proportional to momentum. Momentum represents particle nature, lambda represents wave nature, and the proportionality sign came out, constant came out to be Planck's constant. Thank God you do not have to remember one more constant. Planck was the constant. Planck constant was coming as a proportionality constant. What is its other form? Sir, we very well know momentum is equal to mv. So you can also write h upon mv. In the previous slide, we have done that relationship between momentum and kinetic energy. So in form of kinetic energy, it is equal to under root of 2 mass into kinetic energy, 2 mke. We have done it. Go to that slide. 2 mke. So these are some different forms for de Broglie's equation. Now, moving ahead, some other mathematical forms. Now, if you have to calculate these are questions. I have formulated them in such a way, but these all are questions. You have to calculate de Broglie's wavelength for an electron which is accelerated by v volt. Kinetic energy form I have given you. Potential is equal to work done upon charge. That work done is energy. So kinetic energy can be replaced as QV. So we know lambda de Broglie is equal to h upon under root of 2 into mass of that object into its kinetic energy. Energy is stored in the form of work done. So into kinetic energy can be replaced as QV. So if you know this, V volts are sometimes given to you. What is charge of electrons? Sir, 1.6 into 10 raised to minus 19 coulomb. Put that charge. What is mass of electron in SI unit? Sir, 9.1 into 10 raised to minus 31 kg. If you put all that value and H is a constant, 2 is a constant, means such result will help you like anything. I am giving you the solution for multiplication, division of all those constants, these under root. How much time I am saving? Upon whatever potential will be provided to you, write that potential. And if you do this, whatever wavelength you will be getting, that wavelength will be coming in angstrom. A very important result, my dear students. Please learn this. Now, if you, this can also be written as 12.3, but you will learn this much only. 12.3 under root of 50 is 12.3. Now, moving ahead. Similarly, if sometime questions ask you about proton, so charge of proton changes, charge of proton is same 1.6 into 10 raised to, but mass of proton changes. Mass of proton is 1.673 into 10 raised to minus 27 kg. Put that, the result I suggest, I recommend you learn these results. Why? Tremendously, it will be helping you tremendously in JEE. Saving time. Time is money. De Broglie is equal to 0.286 upon under root V. This will also come in angstrom. If alpha particles, just learn for these three. For electrons, for protons, and for alpha particles. For alpha particles, charge will be 2e and their mass will be 4 times of mass of proton. Because they have 2 proton, 2 neutron. Proton, neutron are same mass, so 4 into mass of proton. Put all that value. What you will find? You will get 0.101 upon under root of V angstrom. These three results are very important. Now, sir, just now you said de Broglie and Heisenberg devastated Bohr. Sir, we haven't seen any devastation in Bohr theory. Let me tell you. If you apply Bohr theory to de Broglie theory to Bohr, what was Bohr's second postulate? Bohr said that orbit can be, that distance from nucleus can only be termed as an orbit where angular momentum is quantized. Remember second postulate, so MVR becomes NH upon 2 pi. De Broglie said, come here. Bohr, come here. Bohr said yes. Tell me what happened. He said, do some maths. Bohr said, okay, what do you want me to do? He said, bring 2 pi r over here. He said, okay. He said, bring NH upon MV over here. Bohr said, okay. De Broglie said, this H upon MV is me, my wavelength. So 2 pi r became N times of de Broglie's wavelength. This result de Broglie reached through Bohr's postulate. Bohr said, so what? What is the difference? He said, what is the circumference of your orbit? He said, circumference of any circle is 2 pi r. He said, how much 2 pi r is coming? N times of wavelength. You know what? Let's say this is nucleus and electron is revolving around the nucleus. From de Broglie hypothesis, Bohr's postulate changed itself. This circumference was not a fixed circle. This was n times of wavelength. Like, how do you draw a wave? Like this. So let us suppose this is one wave starting from here. So this is one wave, this is 2, this is 3, this is 4, this is 5, and I'm just making this is 6. Mind my drawing. So how many waves I have made? 6. So Bohr said this is not circumference of your 6th orbit, because for 6th orbit 2 pi r6 will be equal to 6 lambda, 6 times of wavelength. So this circumference also is not circular. It is 2 pi r for 6th orbit will be equal to 6 times of wavelength. So 2 pi r for 3rd orbit will be 3 times of wavelength. 2 pi r of 2nd orbit will be 2 times of wavelength. So whatever circular orbit Bohr proposed, de Broglie said that circumference is also wavelength. So that circular motion also, that circular motion only failed. Bohr was very sad. To this, one guy came whose name is Heisenberg. Heisenberg came mathematically and experimentally proved what? He proved Bohr. I'll come to this question later. Heisenberg uncertainty principle. He proved, Mr. Bohr, you are giving me radius also of electron. You are giving me velocity also of that electron. He mathematically and experimentally proved that it is impossible. He said, if you will try to measure simultaneously position also and momentum also, it is impossible. Moral science wise, people say everything is possible. I am possible. Remember, those are all moral science statements. It is impossible. What is impossible? You cannot calculate exact position and exact momentum of a particle simultaneously for any matter. This is experimentally proved by Heisenberg. You will definitely do some error. The minimum error that you will do in finding position is delta x. The minimum error that you will do in finding momentum is delta p. This minimum error, the multiplication of this minimum error which you will have to do, is equal to h upon 4 pi. If you are the best, this much error still you will do. Although, if you are like normal people, you will definitely do more error. So this multiplication is greater than or minimum, it is equal to h upon 4 pi. This was mathematically and experimentally proved by Heisenberg. So Bohr theory was completely devastated. Questions of this Heisenberg equation also comes how? This is one form. What is momentum? Mass into velocity. Mass is constant, so will come out. So you can also write it as uncertainty in position into uncertainty in velocity will be greater than or minimum. For questions, you can also equate that it can be minimum, it will be equal to h upon 4 pi. Mass, momentum is mass into velocity, so mass will come over here. So these are two forms of Heisenberg's uncertainty principle. There is one more form also, that is uncertainty in energy into uncertainty in time is also, the error that you will do will be minimum, it will be h upon 4 pi. It will obviously be greater than that, but not less than this. Now, coming to some questions. The question says, if radius of first orbit of hydrogen is a naught. Okay, so What is first orbit, sir? R1. It is given out to be A naught. Formula is R naught into 1 square upon 1 because it is for hydrogen in first orbit. So this is equation 1. It is asking you then de Broglie's wavelength. De Broglie wavelength and radius related J equation. Then de Broglie's wavelength of electron in third orbit. Sir, radius related to wavelength. We have derived the formula. 2 pi r is equal to n times of de Broglie wavelength. Which orbit you are talking of? Third orbit. So what will be the radius of third orbit? 2 pi radius of third orbit. Writing with a pink. Radius of third orbit will be r naught into 3 square is 9 upon z. It is talking for, okay, it is talking for hydrogen only, so z is 1. This is equal to n times of wavelength. What is n? Sir, it is talking for third orbit. So 3 times of wavelength. This wavelength I have to find. What is R naught, sir? R naught is A naught. So instead of R naught, you can write, A naught. So what is your answer? 3133 So this lambda came out to be 6 pi A naught. Do I have any option? Yes. Moving ahead. Next question says, okay, this is Heisenberg done. Uncertainty in position, that is delta x, is twice of uncertainty in momentum. It is 2 times of delta p. It is given. If it is the case, then you have to calculate uncertainty in velocity. Piece of cake. Why? Because we know delta x into delta p is minimum. It is equal to h upon 4 pi. If I'm replacing delta x, so it will be 2 delta p. So it becomes 2 into delta p square. That is h upon 4 pi. What are you asked? Uncertainty in velocity. What is uncertain? What is momentum? Momentum is p is equal to mv. So 2 into m square into delta v square is equal to h upon 4 pi. Mass I have taken out because p is mv, but it is squared. So m square will come out. So here delta v square becomes h upon 4 pi 2 into 4 pi m square. Giving under root, so delta v will be equal to under root of h will be inside under root. This 2 will be inside under root. This pi will be inside under root into what will be out of under root. 4 is 2 square. This is m square. So this is 1 upon 2m. This will be out of under root. Do I have any option? 1 upon 2m. Yes, option C. Moving ahead. Now, moving to the last part of atomic structure, which is the quantum model, which you already must have observed in your inorganic chemistry. So let's start with quantum mechanical model. So to begin quantum model, Erwin Schrödinger was the great scientist. He has recollected all the summary of all those intellectuals moving around the world at that point of time, like Bohr, de Broglie, Heisenberg. He understood one thing. What Bohr did wrong was mathematically he was a genius. But what Bohr did was to be applied on particles with huge matter. There were the macroscopic property of particle, like the mathematics we do for Earth and Sun gravitational system. They are huge mass objects. You cannot apply that maths to an electron because the electron has negligible mass. So also de Broglie said, if particle nature is more, wave nature will be neglected. So for Earth, you neglect wave nature of Earth. But for electron, you neglect its particle nature. Particle nature, the nature due to its mass. You have to consider its wave nature. So that is what Erwin Schrödinger did. Erwin Schrödinger was very successful in writing the properties of electron in a form of a wave. Although in physics you will be studying wave mechanics, but quantum mechanics is completely different from classical mechanics, because what you will be studying in class 11, class 12 physics, what you will be studying in your engineering, that is classical physics. If I'm throwing a ball, that ball has a mass. Quantum physics, if you reach to good IITs and NITs, then maybe, and you'll be further reading further, then you will be studying quantum physics. And you know what the statement of quantum physics? Classical physics fails, then quantum physics comes. So actually classical physics failed to explain the structure of atom, and therefore an independent physics was developed, which is the quantum physics, which completely deals with the wave nature of electrons, and they call wave electron as a wave, an electromagnetic radiation. Now, moving ahead, one point I have to be very clear over here. Here I'm making that distinction between mains and advanced. This is a very good topic for JEE Advanced. Advanced loves it. But for mains, it's a very easy topic. For mains, it's a topic which should lay the foundation of the inorganic chemistry that we'll be dealing with the next classes. For inorganic chemistry and for scoring well, what you need to understand about quantum model, I'll be discussing everything over here. Now, the wave, the eigenfunction parts, the graph parts, which are basically asked in advance, we will be discussing very less on them, spending less amount on them, because we are already over time. So let us begin this discussion of quantum model developed by Erwin Schrödinger. For electron considered as a wave equation was written like, you very well know what is a quadratic equation. What is a quadratic equation? You write as y is equal to ax square plus bx plus c. So mathematically you say this y is a function of x. It can be any function, some log, exponential. These functions you know, and this y is a variable. Y is a variable whose value is depending upon x. So y is a function of x. Electron, when studied as a wave, exists in 3D. So a new function was designed which can deal with x, y, z coordinates of an electron, and this function was named as eigenfunction, or simply wave function psi. Like you differentiate y dy by dx, you double differentiate it d2y upon dx2. This is a double differentiation of psi. But sir, it is only one variable. But for electrons, we have three variables: x coordinate, y coordinate, z coordinate. So you have to double differentiate partially, first with respect to x, then with respect to y, then with respect to z. The Schrödinger wave equation also had this factor of 8 pi square. M is mass of electron, h is again Planck's constant, the square of it, E is total energy, V is potential of electron, and psi is again eigenfunction. Sir, first he was successful in writing this equation. Second, he was successful in solving this equation. And after solving this equation, Erwin Schrödinger, and I mean not only Erwin Schrödinger, there were series of intellectuals involved in the development of quantum physics. But basically what you should know from quantum is they were giving an affirmation after all these huge mathematical outcomes. They were giving an affirmation that yes, you cannot predict where is the electron exactly. You can only talk of the probability. So as of now, whatever science we have reached till now, we do not know 100% where the electron trajectory is. We are only sure about the probability of finding those electrons near the nucleus. And wherever this probability is high, 90 to 95%, we say that is the address, that is the home where electron lives. We are not Schrödinger, the quantum theory said, we do not know whether electron revolves around the nucleus in a we do not know its path. They were in line with Heisenberg and de Broglie, that you cannot know their trajectory. They are so wavish, you can only mathematically You can only mathematically predict their probability. Suppose you come to my home, you ring the bell, I may be found in my place, or maybe I have gone to some hill station for some trips. But yes, what is my address? My address, if you come to my address, the probability of finding me will be maximum. But will I be found in my home all the time? No. Similarly, so whatever outcomes we will be discussing now, you do not have to look at those outcomes in the physical world. Why? Because whatever atom is physically, nucleus, electron moving, how moving, we do not know. So what is this, sir? In order to find that distribution of electron around the nucleus, we have mathematically written an equation. We have spent huge amount of time, huge amount of efforts in solving that equation. The solution of quadratic equation are called roots of quadratic equation. The solution of Schrodinger wave equation are called the address of electrons. So you will find that address in the physical world? No, sir. You are just writing the equation on their wave nature. So whatever now we are discussing over here, these, sir, because it's XYZ, so there will be coordinates XY, but this XYZ will be present in your mathematical modeling, not in the 3D world. You will be knowing the XYZ coordinates of electron, but these XYZ coordinates are not their exact position, they are the probability of finding them. So, keeping things short and sweet, whatever physically atom you know it is done, what is it? I'm ending this discussion now. Nucleus, physically, nucleus, you have nothing. Yes, electron, the probability of finding electron has started. That is energy level 1, not orbit. Not orbit. A quantum said this is energy level 1. What is its energy? I do not know. How far it is from nucleus? I do not know. I cannot be sure. I'm just saying the probability has started increase, energy level 1 increased. Where in this energy level 1, the electron may be revolving. How? I don't know. Yes, probability of finding will be there at energy level 1. How far is it? I don't know. Now, after 1, there will again be a space from 1 to 2 where no electrons will be found. Those places are called nodes where the possibility of finding electron is 0. So once you have found some electrons, you will again go to radially or moving outward. Nothing is found. Then again, electrons probability have started. You suppose you are driving a car. You reach a town. From one town, if you reach outskirts of the town, no people are there. Then when you will find people, when another town is coming, just before the outskirts of that town, you will again start seeing people. So in the same way, this is the atom. Nucleus, energy level 1, it will be some shell sort of radius. So what radius? We do not know. From level 1 till level 2, there are probability of electrons, finding electrons will again goes down to 0. The probability will again start increasing. So energy level 2, 3, 4, 5, this is what atomic structure is practically. Now, the further details we are discussing now, these details, these drawings, you will not try and find in the physical world. They will just exist on pen and paper. On pen and paper, we can draw 3D models. On pen and paper, I can draw XYZ coordinates. So these XYZ coordinates will be there, but they are mathematical XYZ coordinates because they are probability of finding electrons. They are not the complete physical electron itself, because physical electron is a wave. You cannot see a wave. We cannot see electromagnetic radiations. You can switch on your AC, you put on that button on. Do you see any radiation? You cannot see, you can only observe them through their properties. Moving ahead, we have spent so much of time in this. Moving ahead. So this is Schrodinger wave equation. What is significance of the psi? Theoretically, for mains also, you should know certain things. So theoretically, what is psi? Sir, it is a wave function. You already told us. So it's a wave function. It refers to amplitude of electron wave because it's a wave. So amplitude, this basic physics you should know. Main quantum you do in your JEE, in your IITs when you reach IITs. So it's an electron wave. The amplitude is basically represented by this eigenfunction psi. It has no physical significance. I've told you, you will not look for this psi in the physical world. Sir, atom, where is psi? Where is orbital? No. The wave function of psi, okay. The wave function psi, the values, obviously, it is a mathematical function, so it can be positive, negative. Actually, it can be complex also. The iota part can also come sometimes, but that mathematics, the Fourier and Laplace transformations, we do not have to do those. You go to your engineering college and then you'll be comfortable with that maths. So next is all the information about the electron in an atom is stored. Okay, is stored in the orbital. So, sir, what you did? Quadratic equation you solve, its roots are called solution of quadratic equation. Schrodinger equation, once we will learn after engineering or after doing quantum physics in our higher studies after 12th, when we go to our college, we can solve quantum Schrodinger equation. We will find its root solution, sir. Solution will be what? You will not be interested in the direct outcome of solution. What are their values? No. Using that solutions, you will plot a graph, mathematical graph, XYZ coordinates. Looking at the graph, you will see some pictures. And looking at those pictures, in order to assign some name to the pictures, you will say those are the address of electron. And to those address of electron, where probability of finding electron is maximum, to those address, you will refer a name called orbital. Sir, you have taken so much of time. Please cut it short. I am cutting it short. Electron, Schrodinger wave equation written, it is solved. The solution of Schrodinger wave equation are referred by certain set of numbers. Referred by certain set of numbers called quantum numbers. So what are quantum numbers? Quantum numbers are set of numbers, not direct solution, but they are derived numbers which are used to signify the address of region around space where probability of finding electron is maximum. So they are basically address of electron, my address. In order to give a postcard to my address, you need country, you need my state, you need my city, you need my district, and then you need my house number. These 5 data. Similarly, these for electrons, actually 4 data are required. So there are 4 set of quantum numbers which gives you the address of electrons. Now, how this orbital was mathematically extracted from psi? Psi was not used. For extraction, for mathematical extraction, we just have to know this. For those mathematical extraction, so wave function value was not used. Psi square value was used. And therefore, psi square is also termed as the probability density. Because where electrons are found densely, only those regions were termed as orbitals. So psi square gives you, value of psi square actually gives you orbitals. So this I've already told you, orbital is region where probability of finding electron is maximum, somewhere around 90 to 95%. Moving ahead, sir, you said electron live in orbitals. Yes. So now there is no concept of orbit. I do not know orbit. So I know orbital. But I'll not try to find this orbital in physical world. No. Now, sir, orbitals are home of electrons. Yes. Home has address. Yes. What is the address of these orbitals? They are represented by a set of numbers called quantum numbers. They are 4 in number. First is principal quantum number, represented by small n. It tells you what? It is just like Bohr orbit or Bohr shell. Tells you what? About the energy and the size of orbital. For example, their values are 1, 2, 3, like I told you, nucleus, moving. Yes. Probability of finding electron has increased. So this is level 1. From where it has started, I don't know. From where it has extended, I don't know. There will be a putty, there will be a shell, there will be an area, spherical area. This complete area will be, this complete shell will be energy level 1. I know their energy? No. Do I know their distance? No. Does it is a fixed distance? No. It's a shell. So energy level 1. From level 1 to level 2, no electrons found. Node, spherical node. Again, electron started, we again finding electron, level 2. From where extending, I don't know. But this I know. If electron is present in second energy level, its radius is, its distance is larger, its size is larger. Then from 1. Because level 1, you are level 1 student, you are level 2 student, I am level 1 master, somebody else teaching wherever will be level 2 master, somebody else getting higher salary level 3 master. So this 1, 2, 3 are just the numbers which are used to show the 1 is lesser, 2 is higher, 3 is more higher. So this represents the energy and size of orbitals, just like orbit or shell number. Second quantum number is azimuthal quantum number. Azimuthal quantum number is also known as angular quantum number, or because it tells about angular momentum. Remember Bohr theory, MVR, angular momentum. So now we do not have orbit. So quantum theory said, who tells about angular orbital angular about angular momentum? L. So also named angular momentum or angular quantum number, also known as subsidiary quantum number. You just have to remember one name, azimuthal quantum number, and it is represented by L. What does it tell you? This you think, I guess you must be knowing, so I'm just revising it a bit faster. So this designates what? This designates for a particular orbit, for a particular shell, there will be subshell. In a shell, there will be subshell. The designation of the subshell is decided by L. How it is decided? The values of L are dependent on N. What are these values? These values range from 0 to n-1, including the boundaries. So, if, so the range is 0 to n-1, including the boundaries. And if value of L is 0, how you designate the subshell? S. If it is 1, P, if it is 2, D, if it is 3, F, if it is 4, G. Almost G is not required. Whatever elements we know till now, 118 elements, their electronic configuration can easily be written till F orbital. The shape of F orbital we do not define. S is spherical, P is dumbbell, D is double dumbbell. We will be seeing their shape and the nodes associated in the later slides. But this we know. So this L represents the shape of orbitals. The students generally miss. I'm giving you a trick and idea to learn L and the associated subshell. For S, L is 0, you do P, D, F, because while calculating during questions, people misses. So some students I've seen they miss and write, instead of 1 they take 2. So you do this rhyme. You say this when you have to find L for corresponding subshell. You say for S it is 0, P, D, F. P is 1. For S it is 0, P, D, F. For S it is 0, P, 1, D, 2, F3. Got it. Moving ahead. Next. Okay, I told you Bohr theory was negated. So who will tell me that now there is no orbit number? So what will be the angular momentum of an electron? The angular momentum of an electron, quantum said, I am telling you. Bohr, come here. What was it was quantized, Bohr said. What was its multiples? H upon 2 pi, said Bohr said. H upon 2 pi also written as H chi. H and a horizontal bar. Sometimes in questions you can see H upon 2 pi is written as H and a line. Now, instead of H upon 2 pi, the multiplier was not N. Quantum theory suggested that this multiplier is under root of L into L plus 1. This multiplier is under root of L into L plus 1. Hence, L is also known as orbital angular momentum or angular quantum number. Third quantum number is magnetic quantum number. In a shell, what subshell is present? L told you. In that particular subshell, how many orbitals are present? M will tell you. So M gives you the orientation of orbitals, and whatever as per their shapes, there will be some orientation assigned possible. The number of orientations any orbital will have, that many orbitals will be present in that particular subshell. So what will be values of M? From minus L to plus L, because it will be depending upon L. So what are the values of N? From minus L to plus L. Now, these observations you will be doing in a jiffy. Just I need to tell you the application of what have we studied till now. N, L and M. N represents shell number, L represents the subshell present in it, and m represents the number of orbitals in that particular subshell. For example, if L is 1, what are the values of possible values of L? So L values from 0 to n minus 1. So 0 to 1 minus 1, 1 minus 1, 0. Matlab for n equal to 1, you can have only one value of L, that is 0. If L equal to 0, what will be the designation of the subshell? Sir, S. To which energy level it is belonging? 1. So this subshell, my friends, will be written as 1s because belonging to first energy level, and when L is 0, subshell is designated as 1s. Similarly, and for energy level 2, L can be 0 to 2 minus 1 is 1. So L can be 0, L can be 1. If L is 0, subshell is designated as S. It belongs to second energy level, so this is 2s. If L is 1, subshell is designated as P, belonging to second energy level, so 2p. Similarly, energy level 3, how many values of L? 3, 0, 1, 2. Why? Because value of L ranges from 0 to n minus 1. 3 minus 1 is 2. So 0, 1, 2. If L is 0, subshell is designated S. If L is 1, it is designated as P. If L is 2, it is designated as D. So this is 3S, 3P, 3D. Similarly, for 0 to 4 minus 1, 3. So this will be 4S. This will be 4P. L equal to 2. 4D. L equal to 3. 4F. So a particular shell has how many types of subshell? I guess this observational thing you must be observing. If shell number is n, how many subshells it has? N. Because 4 shell has how many subshells? 4. Third shell has how many subshells? 3. Second shell has how many subshells? 2. First shell has how many subshells? 1. So nth shell will have how many subshells? N. And number of orbitals present in a particular subshell is given by types number of values of M, since L is 0. So what will be value range of M? Minus L to plus L. So minus 0 to plus 0. So you can only have M equal to 0. So how many values of M you have? 1. So how many orbital you have in S? Sir, 1. Either it is 4s, 3s, 2s, 1s. For S subshell, you only have 1 orbital because possible values of M is 1 only. The value is M equal to 0. If L is equal to 1, what is the range of M? Minus 1 to plus 1. So it will be minus 1, 0, plus 1. So how many types of values of M you got? 3. So how many orbitals are present in any P subshell? So 3. 4p also has 3. 3p also has 3. 2p also has 3. Similarly, what is the value of L for D subshell? Sir, 2. So values of M, minus 2, 2 plus 2. Minus 2 minus 1, 0, plus 1 plus 2. How many orbitals? 5. Similarly, for F, L is 3, minus 3, 2 plus 3. How many orbitals you got? Sir, 7. Minus 3, 2 plus 3. So if you have understood this, let me give you the last quantum number, the spin quantum number. Why I have written it independently? Because it was independently later on designated and introduced. Why? It is not a direct outcome of Schrodinger wave equation. It was not a solution of Schrodinger wave equation. It is not a solution of Schrodinger wave equation. Very important. You should learn this. You should know this because it's the chronology of quantum physics that is happening right now. Now, it was independently introduced to the people, to the world of quantum intellectuals by other scientists. Why it was required, sir? Because see, for Earth also, there are 2 types of motion. We know electron, if it is in rest, quantum physics would have died. Actually, why? So, if electron is at rest, it will only have one force, electric force. If electron starts moving, it has 2 types of force, electric force and magnetic force, and therefore electromagnetic radiation it is termed as. Sir, ultimately if electron is in motion, so because of motion it will create some field, some force. That force is known as magnetic force. Sir, Earth has 2 types of motion. Sun heavy like nucleus, Earth rotates like this. How much time Earth take to complete one rotation? So 365.25 leap year. So Earth revolves around the sun. One complete circle takes 1 year. 360 1 year. Okay. But apart from this, Earth also do one more thing. Earth also rotates in its own axis. That's why you get day and night. If this is facing sun, it is day. It is rotating, but it is spinning in its own orbit. Spin. So if such a huge body is having two types of motion, don't you feel? If mass is negligible, the lightest electron will also move. Sir, it moves with speed of light. Earth do not move with speed of light. So won't it has also those two types of motion? Yes. So one orbital angular momentum we have already accounted using L. But because it is spinning its own axis, you have to account that also. So if I'm spinning in my own axis, I can move like this or I can turn another way. So I'll have only two possibilities. So later on, the spin quantum number was designed just for those two possibilities. So it is nothing but there are only two values which says that orbital can maximum contain 2 electrons. And those 2 electrons will be having opposite spin. One spin will be designated as plus half and the other spin will be designated as minus half. We'll be discussing a bit about this spin more when we'll be discussing the magnetic property in the later slides very shortly. Now, so from this we know every orbital can have how many electrons? Or 2 electrons. Use it. Okay. They have 2 electrons. Very good. Let us see. Acha, before seeing is, shall I just tell you the rules for assigning electrons to these orbitals? That is the electronic configuration. Obviously, you will be knowing. Let me just browse through that also. So, how many quantum numbers we have? 4. 3 quantum numbers are solution of direct outcome of Schrodinger equation. 4th was independently introduced as spin quantum numbers. We'll be coming back to these slides, but first let us finish this. What are the rules for, sir, now quantum theory can give you atomic structure and electronic configuration and electron distribution of all the multi-electron species. Okay, give me. So they are giving you. Now, how are these orbitals filled with the electrons? There are 3 sets of rules. First rule is Aufbau rule. Very easy. Aufbau says the orbital, you calculate n plus L for an orbital. If n plus L for an orbital is less, its energy is less. If energy less, its stability is more, so it will be filled first. So the orbital which will have less energy is more stable and hence will be filled first. So which orbital will have less energy? Whose n plus L will be less. If n plus L ties, we'll check. So orbitals. Remember that first shell has how many subshell? 1. So first shell has only 1s. Second has 2 subshell, 2s and 2p. Third shell has 3 subshell, 3s, 3p, 3d. Fourth shell has 4 subshell, 4s, 4p, 4d, 4f. Why not written as 4f? Because for these electronic configuration type of questions, till element 30 or still 4th period, we'll be discussing complete in the later chapter of inorganic chemistry, that periodic table and bonding. So basically till 30 the logic gets in. So I've saved time. We'll be discussing in periodic table. So if you calculate the value of n plus L, for 1s it is 1 plus 0. For 2s it is 2 plus 0. Which is lesser? Sir, this is 1, this is 2, 1 is lesser. So whose energy is lesser? 1s. So who is more stable? Sir, 1s. So who will be filled first? Sir, 1s. After that, sir, 2s. After that, do this n plus L for all of them. I am just focusing on the summation. Sir, this is also 3, this is also 3. So if n plus L ties, just for example, it is tying for 2p and 3s. For 2p and for 3s, n plus L value is 3. For 2p and n plus value is 3. So when it ties, you tell me who will have less energy? Sir, it is belonging to second energy level. It is belonging to third energy level. So when n plus L ties, and which the energy level which is less, look at the value of n. So if 2p and 3s are getting tied with their values of n plus l, who will have lesser energy and more stability? 2p. So who will be filled next? 2p. Then 3s. Then sir, 3p and 4s both have value 4. Check. Oh, easy. Who will be filled first? 3p, because n is lower. So 3p. Then not 3d, 4s, because n plus l of 3d is more or 4s is more? Sir, 3s, 4s has n plus l of 4, lesser, more stable, filled first. And after that, 3d. I think you got my point. So you should remember this also. When we'll do periodic table, I'll give you also a trick how to. You do not have to always find n plus l. Periodic table is designed in such a way that it is accounting quantum theory in it. Moving ahead. So after knowing all this electronic configuration, you can clearly write quantum numbers and electronic configuration. These questions are flooded in JEE mains. These are the questions which are actually asked in when a question examiner tries to ask you quantum theory in JEE mains. Electronic configuration and associated quantum numbers are only asked, and this is making a good ground rule for us to start inorganic. So I'll be starting inorganic from the next lectures. High weightage. So now you tell me what is the pattern by which electrons will be filled. Sir, first 1s will be filled, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d. Later we'll see later, because 30 elements will be filled till here. What is the first element? Sir, hydrogen. How many electrons hydrogen has? 1. So where hydrogen will be filled? Sir, 1s. In 1s has how many orbitals? 1. Why? Because value of m will be 0. For s it is only 0. Okay. So where the first electron will go? Sir, in this orbital. How many electrons an orbital can have? Sir, maximum 2. So this is electronic configuration of hydrogen. So what is electronic configuration of hydrogen? 1s1. What are the set of 4 quantum numbers for this electron, valence electron of hydrogen? This is the valence electron of hydrogen. What are the set of 4 quantum numbers? Sir, n, l, m, s. What is the value of n? 1. What is the value of l? For s it is 0. What is the value of m? 0. What is value of s? Sir, it is the first electron, so plus half. You know these questions. I'm just iterating everything. Now, if you do not, if you wish to want me to be more detailed with this, see, atomic structure actually take like 10 to 11 hours because the way we are discussing right now, but I want to save your time. But if even any of you wants, sir, these things, I want some more from you. So, join a channel, or you can comment in the description. I'll try to connect with the detailed analysis of whatever part you want me to elaborate. So, now, this is 1s. What is, how many electrons? Helium has 2. So, how many electrons will be filled? 2. Sir, 1 is filled over here. Where will the second one will go? Sir, it will be going in this orbital only, but with opposite spin. How you represent opposite spin? Like this. What are the 4 set of quantum numbers for the last and valence electron of helium? Sir, value of n, l, m, s. N is 1. L is 0, M is 0, but S will be minus half because they are 2 different electrons. So all set of 4 quantum numbers will not be same for them. This we know from spin quantum number also, and actually this is one of the rule. This is Pauli's exclusion principle, which says one orbital can have maximum of 2 electrons, and both those electrons have different value of S. First will have plus half, second will have minus half. This we already know when we have assigned spin quantum number. Now, where the third electron will go, now you have to do it by yourself. Third is for lithium, fourth is for beryllium, then for boron. I am not speaking those 10th class thing. Now I am just giving you the electronic configuration. First has gone over here, second has gone over here. Now, this is third, this is fourth, this is fifth. Now a question will come to your mind. Sir, where sixth will go? Because from 2p subshell, it has got degenerate orbitals. Sir, what are degenerate orbitals? 2p has n plus l of 3. This subshell has how many orbitals? 3. So all these orbitals are of equal energy. So because all of them are of equal energy, or these equal energy orbitals belonging to a similar subshell are called degenerate orbitals. How are they filled, sir? Hund's came into picture, and Hund's gave a rule of maximum multiplicity and said, if you land up with degenerate orbitals, you do not pair them. First, make the subshell completely filled singly, not completely. Make those degenerate orbitals singly filled. Do not pair them. First, fill all the dabba, first fill all the boxes, first fill all the orbitals singly. So if fifth electron, I'll just write the number also so that you may remember this. If fifth electron has gone over here, sixth will be going over here and seventh will be going over here. So if this is fifth electron, so this will be sixth, this will be seventh. So you tell me where is I'm using red. Eighth electron will be coming here. Ninth, I missed it. Ninth will be coming here and 10th will be coming here. So why electrons are filled in this fashion? Reason, because pairing in degenerate orbital will only be done when it is singly filled. So if someone asks you for example, for carbon has how many electrons? 6. So 1, 2, 3, 4, 5th and 6th, this green one. So for this 6th electron is the valence electron. So for this electron, what are the set of quantum numbers? N is 2, L is 1 because for P, L is 1. M, sir, -1, 0, +1. So it will be 0. And what will be the spin S for this green? It will be +12. Moving ahead. So now it is a piece of cake for you. So this is 10. So this is 11, 12, 13, 14, 15, 16, 17, 18. So 18 turn till here. Then 19, 20. Then 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So till 30 and for even more also, this is the way you can write electronic configuration of elements also. You can know the quantum numbers of the last electron also. Yes, chromium and copper has some exception. I'll be just discussing them. But after we just finish off with this quantum numbers, basic observation. We have done everything. Now some basic observations after studying all these things. What are those basic observations? First, I'm asking you, if shell number is 1, what is if shell number is n, what is the total number of orbitals you can have? Just look at this photo. First shell has 1 orbital. Second shell has orbitals, not subshells. These are subshells and the dabbas, the boxes are orbitals. Second shell has 4. Third has 4 and 5, 9. Fourth has 9 plus 7, 16. So this is an observational math, no rocket science. Because first shell has 1 orbital, second has 4 orbital, third has 9 orbital, 4 has 16 orbital. So by this observational analysis, this is no into divide, observational analysis, no derivation. So if shell number is n, then in that particular shell, total number of orbitals will be n square. And through Pauli, I know how many electrons one orbital can have 2. So total, if I give you shell number n, what will be the maximum number of electrons present in that shell? Sir, 2n square, because we have n square orbital. Every orbital can have 2 electrons. So maximum number of electrons will be 2n square. Moving ahead. If for a subshell with a given L, for a subshell you will know it's L. What is the total number of orbitals? Now I'm asking you, give me a general formula for total number of orbitals in a particular subshell. If I know its value of L. So for example, subshell, like when L is 1, subshell is P. How many orbitals it has? 3. Why? Minus L2 plus L. So minus L2 plus L. So the formula will be 2L plus 1. So this is a general formula. You should know these observational formulas. Now, for NH shell, total number of, for NH shell, I've just now told you, orbitals are n square. So for NH shell, total number of electrons will be 2n square. Also, if I'm asking you total number of subshell in nth shell, this I've already told you. What? If shell is 1, subshell was 1, shell was 2, subshell was 2, 3, 3. So for a nth shell, if my orbit number is, shell number is n, how many subshell I'll have? N. So these are some observational questions which I think you should know. And moving and almost finishing to this part, I give you the orbital shapes. Yes. Orbitals. What are the shape of orbitals? Value of L tells you how to designate. It also tells you the shape of orbitals. The shape of orbitals we have plotted. How we have plotted? I just give you an example. Some mathematics was done. Schrodinger equation solved. We get XYZ coordinates. So this heavy mathematical modeling, how we have simplified it, where you can find that those redness, you encircle it. So that will be the probability where finding electron is. There is, I mean, orbital is nothing. We are just encircling such an observational, calculative, mathematical approach. So in order to encircle this, in order to get a region, what you did is made a lobe. Hence the shape came out to be a dumbbell. So this is for P. Similarly, for S, I know it's a spherical shape, so it is a 3D sphere where electron, the probability of finding electron was getting maximum. So how we draw it? Like this. But how mathematically modeling, we have got the values of eigenfunction psi, xyz. Now I'm stopping this now because too much time. But I hope I've made you feel this. So this is shape S. So S orbital is what shaped? Acha. Orbitals are always written in a smaller letter. So S is spherical in shape. Okay. Do I have any plane which this sphere can be cut through? No. So actually nodes, what nodal plane for S is 0. First, let me tell you the shapes. P has dumbbell shape. You can clearly see this is a nodal plane. Over this plane, no electrons will be found. See, whiteness, this. So these are nodal planes, but you should know nodal nodes also. I'll be just giving you a basic conclusion, but just to make you feel. So this is dumbbell shape. The D are 5 in numbers. This is, acha, if this is Px, if lobes are lying along x-axis, this is Py, this is Pz. Okay. This is Pz. I just make it brighter. This is Z because lobes are lying along z-axis. This is Px because lobes are lying along x-axis, and this is Py because lobes are lying along y-axis. So how many P you have? 3. Px, Py, Pz. How many D you have? 5. D are of basically 2 types because they are double dumbbell. So when their double dumbbell lie in between the coordinate axes like dxy, dyz and dzx. If this is what? dyz. So if this is dyz, then this is y-axis, this is z-axis and this is x-axis. You can clearly, this is a 3D model. Y-axis, z-axis and x-axis in and out of the board. So when for P dyz, this is yz, so this will be yz plane. So where the lobes are lying, sir, in between the coordinate axes and on the yz plane. In between the coordinate axes and on the yz plane. Similarly, P dxz will be lying on the xz plane, but the lobes will be in between the coordinate axes. Similarly for dxy. Electrons are found on the xy plane, but lobes are found in between the coordinate axes. Moving ahead. What is dx2, y2 and dz square? In these d orbitals, electron orbitals lobes are found along the coordinate axis just like P. In P, electrons were found along the coordinate axis. Here also they are found along the coordinate axis. So they are present along the coordinate axis. This is if present along x and y axes, this is x2, y2. If present along z axis, This is dz square. But dz square has a Saturnian lobe as well. What is a Saturnian lobe? You must have seen Saturn, because electrons are found as a tire tube. When you go to swimming pool, this is you and then a tube. So again, two double dumbbell, one dumbbell and second dumbbell. So these are shape of d orbitals, and when you know the shape, it is very easy for you now to understand what are nodes. Nodes are region where probability of finding electron becomes 0. Nodes are region where probability of finding electron becomes 0. Nodes are generally of two types. Nodes are generally of two types. First type is called a radial node, and the second type is called an angular node. Again, because quantum numbers are direct outcome of are conclusions of Schrodinger wave equation and wave model. So whenever in that mathematical model, that theoretical mathematical model which has no physical significance, you will be finding some region where electron are there. Now it has gone, now again came. So that region where it has gone are the nodes. They are of two types. Radial nodes, as in from radially, if you are moving from the 0 of xyz, if you are moving radially, the region that you are getting where electron probability has become 0 are called radial nodes. And if you try to cut a plane, and through that plane, if there are no electron meeting or lying in that plane, that is an angular node. So by observational mathematics, statistical mathematics, not a derived formula, number of radial nodes are equal to n minus l minus 1, because they are dependent on quantum numbers. And number of angular nodes are nothing but L. So you tell me, what is, if these are two types of nodes, so what is the formula for total nodes? Sir, nodes are of two types, radial plus angular. So total nodes be equal to, for any orbital, total nodes be equal to radial node plus angular node. What is the value of radial node? N minus L minus 1. What is the value of angular node? Sir, L. LL got cancelled. So how many total nodes you will have? Sir, n minus 1. You can simply go to your PYQs, and it's very simple, very simple. After you just have to pay attention to this quantum class, and every mains question will be a piece of cake for you. So after discussing these nodes, let me give you this picture also. For example, okay, let us calculate number of nodes for them. So for 1s, radial node is 1 minus 0 minus 1, n minus l minus 1. So radial node is 0. Angular node, what is the value of L for S? Sir, 0. So how many nodes it has? 0. See, from center, electron density is there? No node. When you can say node is present, when you find an electron, and then you find a region where there is no electron, and then we again find an electron. So here you found an electron, and after, sir, you say, sir, this is infinity. So at infinity there will be, at infinity you do not consider node. You consider node in between. You found something like for 2s, I'm telling you, you'll get it. Infinity you do not consider as node. So 2 minus 0 minus 1, so radial nodes will be 1. Angular node will be 0, because for S, L is 0. So total nodes are 1, but that node is a radial node. So if you move radially from the origin, so this is origin, I found an electron. Again, there is a place where electrons are not found. So see, you found an electron, and now this white space is a region where you didn't find any electron, and then this again gray region, you again found electrons. This again gray region, you again found electrons. So when you're moving radially, you found electrons. A region came where electrons probability became 0, and then again it got increased. So how many radial nodes? This white area is the nodal surface, is the nodal spherical surface. Hence, radial node is 1. Similarly, for 3s, you found electron, first node, you again started finding electron. Second node, you again started finding electrons. Because you can definitely know this, that if this is 3s, If this is 3s, then this will be 2s electron density and this will be 1s electron density. You know, 1s, 2s, 3s. So how many nodes? Let us see. From formula also this will come. Radial node is 3 minus 0 minus 1. See, radial nodes are 2. Angular node, for S, angular node is always 0 because for S, L is 0. Coming to P. For 3P, let us do see this through picture as well. For 3P, what will be equal to radial node? 3 minus 1 because L for P is 1. So this comes out to be 1. What is angular node? Sir, for P, L equal to 1. So how many total nodes it has? 2. 1 radial, 1 angular. How 1 radial? You can, I guess now it has become much clearer to you. Let me make a picture also so that it becomes quite clear. This, sir, you are talking of 3P. Think. Inside, sir, 1p. 1p does not exist, sir. 2p. 2p exists. So those 2p electrons exist. So from origin, if I'm moving radially, I found electrons. Then there is a region, this light pink region, the spherical node region where electrons are not present. Then again we are finding electrons. These are also dumbbell sort of thing. But because these dumbbell I have to make bigger because 2p is smaller, 3p is bigger. So this is 3p. So 3p has how many radial nodes? Sir, 1. What is that? Sir, from 2p, if you move till 3p, a node will come. Infinity, you do not consider a node. Center, you do not consider a node. As I told you, you get some electron density, you do not, that becomes 0, and again you get that surfaces at nucleus and at infinity. Nodes are not counted. Now, how many angular node? 1. That you can, I mean, apart from this, you can clearly see if I'm making, let's see, if I'm making a p orbital. You cut a plane. So this is an angular node. So for just one more, for d orbitals, how many nodes you can have? Let's say any d, 3d. How many nodes you can have? So 3 minus, for d, L is 2 minus 1. So radial node is 0. But for 3D, angular nodes are 2 because for D, L is 2. Sir, how? Go to those pictures. Go to those pictures. What pictures? Shape of orbitals. See, if this is dxy, dyz, dzx, I'm just making dxy, dyz in a simpler manner in 2D. That will be easier for you. See. This is in between the coordinates axis. If it is x-axis, if it is y-axis, then this is dxy. So electrons are lying over here. So this will be one plane. This will be yz plane. This will be that yz plane. If you cut that plane, no electrons will be found. And it will be xz plane. It will be xz plane. So these two planes will be the nodal planes. Sir, for these three, we can see, for this also we can see this, this here electrons are lying, like I draw. See, 3D image is, you can for 3D image, if you can draw 2D, it will be much easier for you. So if it is x-axis and if it is y-axis, this is shape of dx2, y2. So you tell me, what are the planes where no electrons will be found? Sir, cut a plane like this, like this. This will be one plane. So 2 planes, 2 angular nodes. Now, sir, how come electrons are here also and on xy plane also in that Saturnian lobe? It contains conical nodes. Shankar ji ka damru, conical nodes. As in, if you make a cone, a 3D cone. So in this cone, triangular cone, can't you see you are not finding electrons? So this is one cone. This is another cone. So dz square also has 2 angular nodes, but those angular nodes are what? Name is angular nodes, not planes. Angular nodes may be planes. Angular nodes may be any angular object. Like for dz square, they are cones. Moving ahead. So moving forward and brushing this basic ideology that, sir, if Bohr theory is so wrong, then you have discussed so much of quantum model, then why we are still practicing those calculations for single electron species in Bohr theory? Actually, quantum theory also supported the fact that for hydrogen, whatever Bohr calculations are observed are still more or less valid, because approximately you can calculate things, you cannot be sure. Bohr just did that, he was sure. So actually, quantum theory also said that for hydrogen, the energy only depends on the value of principal quantum number, and for all other multi-electron species, energy through above we know it depends on the value of n plus L. So keeping this basic, which we have already seen, what are degenerate orbitals? Those orbitals of a subshell which have same energy. So if I ask you that what is the ground state orbital degeneracy as a number of orbitals, so what is the ground state subshell? The subshell with lowest energy is 1s. What is its degeneracy? That is how many orbitals it has of similar energy. So 1s has 1. So first excited state, sir, 1, because second is 2s. Then 2p has what degeneracy? 3. Then third excited state of multi-electron species is subshell 3s having just one orbital. But for hydrogen, we know for hydrogen, L has no contribution. The value of energy only depends upon principal quantum number as Bohr suggested. Therefore, what is the n plus L rule? Sir, if L gone, then it just depend upon the principal quantum number, that is orbit number. Yes. So if somebody asks you for hydrogen, what is the degeneracy of ground state? Sir, ground state is still 1s, because first shell has only 1s. First shell only has 1s subshell which has one orbital, same. But first excited state will become second shell, and value of energy of 2s and 2p for hydrogen will be same, because L is not playing any role. So if somebody asks you what is the degeneracy of first excited state in case of hydrogen, so answer would be there are 4 orbitals which have equal energy, so degeneracy will become 4. But for multi-electron system, for first excited state, degeneracy is 1. So for second it is 3, but here for second it is 1 plus 3 plus 5, that is 9. So this is a very general concept which JEE asks. This picture is even given in NCERT. So moving ahead. So before finishing and starting off with the orbital distribution graphs and the equation, we missed a few things, like why the fully filled and half filled orbitals are more stable. So in order for that, first you need to know what is the order of stability of orbitals. So I guess we very well know this. Fully filled orbitals are most stable, followed by half filled electronic configuration, and whatever subshell electronic configuration may be, that is very less stable actually. So now let me give you a frame to show what's a fully filled configuration. A fully filled configuration is when all the degenerate orbitals are completely filled, and half filled configuration is that when all the degenerate orbitals are singly filled, and any other cases is a case of partially filled configuration. Now, so students ask, sir, why fully filled and partially filled and half filled are more stable? The two reasons given in NCERT, although you should just know them theoretically. Sir, symmetry always provides stability. So because they are symmetric, therefore they are more stable. Second thing, the exchange energy. More be the number of symmetrical distribution, more exchanges can take place. If electron exchange between themselves, more exchanges releases more energy. More energy is released, that means energy of the system is decreased. Energy of the system is decreased, that is system becomes stable. So these all provides stability to the definite electron, to a given electronic configuration. Now, one more thing we left, exceptional electronic. Now you know Copper and chromium, because of that half-filled and fully filled configuration, their electronic configuration as per rules of electronic configuration that we just completed. What was that? Aufbau, Horn-Sand, Pauli's exclusion principle. So chromium and copper till argon 18 both will be filled the same. After filling of this 18th electron in 3p, according to Aufbau, which subshell to be filled? 4s. So those two extra electrons will go to 4s. How many electrons we have filled? 20, both in case of chromium and copper. So 20 filled. How many more you have for chromium, sir? 4. So it will be filled in 3D. So it should have 3D4, 4s2. Whereas copper should have 3D9, 4s2. But since we know half-filled and fully filled configuration provides a lot of stability, so why these atoms will remain unstable in nature? Because God has given them this grace. What is the grace? The grace is 3s and 3p, the third shell is completely filled. If this 3D in both cases of copper and chromium stabilizes itself, the whole third shell becomes stable. So even though 4s has been filled before, that is in accordance with Aufbau rule. But ultimately, fourth energy level is the outermost shell and third is the innermost shell. So in such cases, what these copper and chromium 4s electron do is, the one that I have mentioned with the green color, they migrate to the inner shell, thereby making it a half-filled and a fully filled configuration. So instead of 4s2 3d4, the configuration of chromium becomes 4s1 and 3d5, half-filled, stable. Similarly, instead of 4s2 3d9, it becomes 4s1 3d10. We will discuss more about such electronic configurations when we'll be starting with inorganic chemistry, probably the next one. Moving ahead, now one more thing we missed, magnetic properties. While discussing value of L, I told you it is also known as orbital angular momentum. Okay. While discussing spin quantum number, I told you atom has two types of motion. One is circling around the nucleus and other one is motion in its own orbit, the spin motion of electrons. So because of motion of electrons, one extra energy it acquires. What is that energy, sir? Magnetic energy. It acts as a magnet because of its motion. Because of motion of electrons, it acts as a magnet and its magnetic moment is calculated using its magnetic moment. Now, why sir magnetic moment? Over there you said orbital angular momentum. What is magnetic moment? You know, because of presence of unpaired electrons, those atoms present in many substances will make them magnetically active. So therefore, speaking about some of the magnetic properties, basically, if at all I am magnetically active, I can show that activity in two ways. What are those two ways? I can either get attracted by external magnetic field or I can either get repelled by external magnetic field. If I am getting attracted by external magnetic field, I am called paramagnetic. If I am getting repelled by external magnetic field, I am termed diamagnetic. Now, presence of unpaired electrons, because my electron is unpaired, it has not paired itself. Nature has not given me so many electrons that I can pair my electron. So what I'll do is I'll try to cancel my magnetic moment with the external magnetic field and hence I get attracted towards that field. And if all of my electrons are paired, we are happy. All of our electrons are completely paired. So we will not entertain such external magnetic fields. If those external magnetic field comes, we will repel out of it. So diamagnetic substance, because of presence of paired electrons, gets repelled. Paramagnetic substance, because of the presence of unpaired electrons, get attracted to external magnetic field. This is the thumb rule. Okay. Now, what is the extent of magnetism? If I am more paramagnetic or that person is more paramagnetic, how will you measure that? You can measure that by presence of unpaired electrons. And the measure has been formulated with the term magnetic moment represented as mu. This mu is nothing but it is equal to under root of n dash into n dash plus 2. References take n. I am asking you to take n dash. Why? Because n is used for mole. What is n dash? N dash is number of unpaired electrons. So you write electronic configuration, you count the number of unpaired electrons, use the formula. That in the unit is known as Bohr magneton. So this is how you can quantify the extent of paramagnetism. Sir, if I have no unpaired electrons, n dash will be 0. So for diamagnetic substance, magnetic moment is 0. You will get so many questions on these topics as well. That's why, since we missed it, I've taken it in the last. Now, one motion is also due to spin. So because of spin also I'll create some magnetic moment. So due to spin motion, the magnetic moment I create can also be calculated using the formula. These all are statistical formula, not derived formula. So you should know them, you should learn them. So this formula is under root of capital S into 4s plus 1. Now, sir, what is this S? This S is total spin of any system. Sir, give us an example. For example, you have any 3D7 configuration. So you just tell me, in this 3D7 configuration, how many electrons you will be filling? 7. How you will be filling? First 5, then pairing. What, sir, plus half of this spin, minus half of this spin, cancelled. Cancelled, but this is unpaired, sir. So it will have some plus half spin, plus half spin, plus half spin. So how S will be equal to, you have unpaired spin. How many? 3. So plus half into 3. So value of capital S, the total spin will be this. Put in that formula and you will calculate the spin magnetic moment, because spin is also a motion, and because of motion, every species creates magnetic field. Lastly, probability and probability distribution functions. Now wave function, actually I told you advanced topic, but just a brief about it. We know wave function. When you solve wave function, what are the direct solution of Schrodinger wave equation? 3 quantum numbers n, l and m. S is not a direct outcome of Schrodinger wave equation. So psi, when solved in form of n, l and m, the basic structure of the reaction, this is rarely discussed in any class. The function that you find is something like this. It has a structure. The Schrodinger wave equation phi function has a structure. Psi function has a structure. It must contain a constant part. This constant part may be, number of set of numbers. So there must be some one thing must be constant. It should also contain a polynomial. Polynomial with respect to radius, that is distance from nucleus. So this polynomial, the power of this polynomial is generally decided by n minus l minus 1. Remember the radial notes? A sigma factor, what is a sigma factor? This is nothing but the atomic number of that atom, radius from the nucleus upon a naught. A naught is the Bohr's radius. So this sigma factor containing the R thing, this has a power of azimuthal quantum number L. And it should have it has a exponential factor also, e raised to power minus this sigma upon n. N is again that principal quantum number. So every wave function for every orbital must lie in this fashion. For example, do not see that I've written it for 3s. If you know this common sense, you can apply. I have to observe that this wave function is for what orbital. Let's say I do not know it is for 3s. Actually, it is for 3s. So quantum physics, I'm giving you this. So it should contain some constant. Can you see constants? Yes, sir. We can see constants. So this is the K part. Can you see a polynomial in R? Yes, sir. What is the highest power of the polynomial R? Sir, 2. That means highest power, that means n minus l minus 1 value is given out to be 2. This is your first observation. Do you see any other function where R is mentioned? Sigma R upon a naught? No, sir. After this polynomial, we cannot find any R function. So this R function is not existing. That means sigma has definitely a power of 0, because anything having power 0 is 1. Because it is not present. So this is, sir, through this we directly can see L is 0 for this orbital. So definitely L is 0, that means it's an S subshell. Now, if L is 0, what is the value of N? Sir, N minus 0, sir, N is 3. That means what orbital it is? 3s. Similarly, some advanced questions are, they give match the column. They are crazy about this stuff. You just remember this pattern and every wave function you can decode. Now, last thing, probability density and probability distribution function. We know what is probability, sir. Probability wave amplitude is psi. I'll just make this graph for one orbital, for one element, for one orbital. Let's say I'm making it for, let's say we make it for 3p. So in order to draw their wave functions, you can also, you do not have to do experiment. You can do this through common sense of quantum theory. What is it? 3p. What is the total number of since I am plotting a graph of their wave functions with distance from nucleus r, so I'm interested radially how many nodes are present. So what is the formula of radial nodes, sir? N minus L minus 1. What is value of L for p? Sir, 1. So how many nodes it will have? 3 minus 1 minus 1, as in it will have only one node. Okay. So now what is the structure, shape of p orbital, sir? At the origin, at 0, at center, probability of finding electron term 0. That's why it starts with a 0. I mean, at the center, there is no probability. If it would have been an S, probability at the center was maximum. That's why it's a sphere. So why you are saying this, sir? Because psi, probability of finding at the center is 0. The probability increases, then turns 0 because there has to be one node. Then again it acquires a maxima and then it approaches 0. Nodes at the center and at infinity are not counted. Probability has to increase, and when it turns 0 and again increases, again you start finding electron. Only this point is termed as node, and since we have one node, so I have just done this one time. Sir, this is a wave, so we know wave has positive notion also, wave has negative notion also. So this will be the graph for wave amplitude of 3p orbital. Now, what is probability density, sir? Square it. So if you square it, the negative part becomes positive. Okay, its magnitude will increase. With the magnitude, I'm not interested. So what I can draw now is, sir, there will be a maxima, it will turn 0, and then again there will be a maxima, and then it will be approaching to 0. Because this positive remains positive, this negative becomes positive. Sir, the value will also increase. I am just talking of the notion. Do not worry about the values now. Sir, what is probability distribution function? Probability density, mass equals volume into density. So, if this density is multiplied by mass equals volume into density. So, if this density is multiplied by volume of that shell where it is spherically available, volume is 4 pi r cube, 1 r square and another this r will make it 4 by 3 pi r cube. Almost basically, multiplying it by volume, what you get is probability distribution function. So probability distribution function has a term of r in it. So when r is 0, it has to be 0. So these graphs, how you make? You just, sir, because r is there, so they'll definitely start with 0. How many nodes you have? 1. So you attain a maxima, come to a 0, you again attain a maxima, and then you approach 0. Mind you, because r factor, square of r factor is also there in the y-axis, therefore these peaks will always be increasing. I am not telling anything about their maximum minimum value, but probability distribution function, this peaks always keeps on increasing. So it's an increasing peak graph. You just have to know what are the number of nodes. So these are the graphs for 3p. Similarly, you can draw for other orbitals as well, but that is basically an advanced topic. So this is how we have completed atomic structure. I hope you liked it. You have to revise it so many number of times. If you do not have to make notes, just make whatever you feel is important, because this chapter is at least one question, and in physics also sometimes with this theory you can make one question in physics also. So a very, very, very important chapter. Also, this electronic configuration forms a base for the entire inorganic chemistry that we'll be discussing. So just sit back and work hard. All the DPPs, the lecture notes, these notes and the assignment that I have given you will be available in the PW app. So you have to go check the description box, log into PW app and enroll to Elevate JEE crash course. You'll be getting all this stuff. Spread the news, and we'll meet in the next lecture. Thank you.